So as I mentioned to you previously in the mathematical logic, whatever happened, revise one time. Any doubt there, ask in the group. Definitely I will help or someone else will help. I'm able to see in the group some people posted some doubt. Maybe after class, if at all still if your doubt is there, after class I will check. Right? Now concentrate here. Right? Graph theory. It is coming every year, right? Every year it is coming. Either 2 questions are coming sometime 3 questions are coming, but it is a guarantee that Atul saying no voice. Is it so? Atul saying no voice. Is it so? Lower than usual. Okay. Any voice controller here? Yeah, fine. It's fine now. It's fine. Maybe your side problem. So every day I'm doing same. Every day I'm doing same laptop, everything same, right? Don't blackmail me emotionally. As usual, it's not coming, something else coming. Don't blackmail me emotionally. Every day same only going on. Every day same only going on. Right? No emotional, nothing. Yeah, perfect. Good boy. Now see this. So graph theory, right? So as I mentioned to you, minimum 1 question coming. Sometimes 3 questions also coming. Concentrate here. So everyone know what is the graph definition? Everyone know what is the graph definition? Graph G is nothing but a combination of V and E. Graph G is nothing but a combination of V and E. That is the graph definition. Graph G is the combination of V and E, right? So where V is vertices, I'm writing set of vertices. Set of vertices, E is set of edges. It will take few minutes, please take care. V is the set of vertices, E is the set of edges. Right? Everyone know this. Right? So, small example. V1, V2, V3, V4. These are the 4 vertices. Every circle is a vertex. These are the 4 vertices, and between 2 vertices, one line there, that is called edge. If you want to give the edge numbers E1, E2, E3, E4, and E5. Graph G is the combination of V and E, where V is the set of vertices, E is the set of edges. The edges also there, E1, E2, E3, E4, E5. Right? So if you want, I will write vertices are these. V1, V2, V3, V4, yeah, that's it. And set of edges. E1, E2, E3, E4, E5. Yeah, let me know if anyone having any doubt. Yeah, let me know if anyone having any doubt. So simply graph definition, one example I give. I'm not done anything new. Please learn this habit. Topic wise, please go. Don't say DMS, I'm not okay. Say which problem not okay, which topic not okay. Don't say superset itself, I am not okay. Some people will say DMS, I am not okay. Some people will say, right? Some people will say GATE CSE, I am not okay. Some people will say, right? I hate human life. Some people will say, I hate India. See the people. Big thing, supersets. One person say, I hate DMS. One person, I hate GATE CSE. One more person, I hate my life. One more person, I hate India. Who asked you to forcefully stay in India? Get out from India. Who asked you? Yeah. Right? So please, whenever something is not okay, identify what is not okay. Please work on that. So if you work, listen, if you work 1 more hour extra, Total DMS will come. Why you leave the DMS? Of course, everything cannot come as you planned, right? Some things may go against you. Please find out. Oh, this is going against me. Please find out. Do 1 or 2 revisions. Everything okay. One student not listening my words. I am saying to everyone, right? Everyone listening. One person not listening, right? So I will take this. Do like this. Over. You will listen. You will listen. Am I right or not? Everyone listening. One student not listening. Do one time like this. Dum, 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 dum. Do like this. Then everyone will listen. So what I mean to say is, in the similar way, in the discrete mathematics, one problem not listening. Take that problem, catch this one, beat like this, then problem will come. In the sense, spend some time, respect it. When something is not working, please respect. What is there in that? Please respect, yeah. That's why online I choose. Means you got offline beating. You got beating offline. Do you think I killed many people offline? I killed many people offline like this. If you come offline, trust me, if you come offline, I will take knife. Do like this, over. Just like this, over. If you come offline, I don't beat you. If you come offline, no beating, bhaiya. No beating, just taking knife. Just do like over. Just I will say sorry. Arey Hayden, do you think Jaya required gun? Arey man, do you think he required gun? Someone is saying that Aditya Bahuguna saying that nice game going on. Arey dog, you came today only. See everyone. This dog came now only. This name is called Aditya. This dog came just now. He is also playing. See, he is also saying nice game going on. This doggy joined just now. That's why, sir, let's start. Please, new stickers getting ready. Okay, fine. Okay, listen, everyone. Everyone listen. So, graph definition is a combination of V and V. V is set of vertices. T is set of edges. So, I written the one diagram also. Everything is fine. Can anyone help me? The diagram which I drawn, any direction or no direction? The diagram which I drawn, is there any direction or no direction? No direction. No direction means what? Edge E1, V1 to V2 you can write. V2 to V1 also you can write. It's an undirected graph. If you keep directions also, then it's a directed graph. It's an undirected graph. And one more thing I want to ask you. It's an undirected graph, okay? It is an undirected graph, okay? And one more. Can help you know, on every edge, weight is there or not there? On every edge, weight there or not there? On every edge, weight is there or not? Something like this one. V2 to V4, edge is E4, right? Weight is 25. If I keep like this, that is called weighted graph. Because of now, no weights are there. Unweighted graph. It's called unweighted graph. No weights. It's called unweighted graph. Right? So, but the thing is, listen, weighted graph you will discuss in the algorithm, right? Minimum cost spanning tree, single source shortest path, there you will discuss. Right? In algorithm, weighted graph is required. In the graph theory, there is no weighted graph. Are you getting? In the graph theory, there is no weighted graph. Suppose weighted graph is there. So in algorithm, right? Maybe shortest path. Whenever you say shortest, oh, smaller one, means cost less, means weights are less, something like that. In algorithm, maybe you will study that. Right? Okay, fine. So remember this graph is an undirected graph. This graph is an unweighted graph because on every edge, no weight is there. Unweighted graph. Remember, unweighted graph, right? Unweighted graph, every edge by default weight is 1. Right? But that unweighted graph means by default edge weight 1. By default edge weight 1. By default means if you don't keep anything, If you don't keep anything, by default edge weight 1. If anyone asks you, right in the unweighted graph, what is the edge weight? So keep just simply say every edge weight is by default 1. What is the meaning of by default? If no edge weight is there, by default 1 you get. By default, every edge weight is 1. So until now, anyone having any doubt? Directions are there, so undirected graph. Edge weights are there, so unweighted graph. Fine, are you okay? Till now, are you comfortable? Everyone know. Just I'm introducing, right? Small basics one time. Because of everyone studied algorithm subject, most probably everyone studied algorithm subject. There you already got all these things one time. Now, next one. Come to the next line. Come to the next line. Everyone listen. Come to the next line. Everyone have to understand. Come to the next line. See this? See this one? Between V3 and V4, between V3 and V4 edge there. Then I can say V3, V4 adjacent to each other. Between V1, V3, between V1, V3 edge there. Then I can say those two are adjacent to each other. So V1, V3 adjacent. Because whenever between two people edge there, then I can say those two are neighbors. V1 neighbor is V3 because between them edge there. I can also say that V1 adjacent is V3 or V1 neighbor is V3. Now it's the correct time to ask you for the V1, how many people are adjacent? Between two people edge there. Between two people edge there. Between two people or two vertices edge there. Edge there. Then I can say that those two are adjacent to each other. Then those are adjacent to each other. Between two vertices edge there, then I can say those two are adjacent to each other. Can you say vertex 1, how many people are adjacent? Vertex 1, how many people are adjacent? I think vertex 1, 3 people adjacent. 3 people adjacent. Remember vertex 1, 3 people adjacent. That is called degree of vertex 1. So degree of V1 is 3. 3 people are adjacent. Next one, vertex V2, how many people are adjacent? 2 people. Degree of V2 is 2. 2 people adjacent. What is the degree of V3? Degree of V3, how many people are adjacent? 2 people. What is the degree of V4? How many people are adjacent? So 3. Right? For a particular vertex, how many people are adjacent? What is the meaning of adjacent? Between two people edge there. Then I can say those two are adjacent. Then for V1, how many people are adjacent? 3 people. So degree of V1 is 3. Degree of V2 is 2. Degree of V3 is 2. Degree of V4 is 3. Is there anyone who is having doubt till now? Do you have any doubt till now? Degree of every person you got. Degree of every person you got. Hello. Is there anyone who have doubt? Degree of every person you got. Write the definitions also properly. If anyone don't know, please write the definitions properly. Between two vertices edge there, then I can say those two are adjacent to each other. Next one, V1, 3 people are adjacent. So degree of V1, 3. Degree of V2, 2. Degree of V3, 2. Degree of V4, 3. So like that. Now listen everyone. Everyone listen one time. So degree of V1. Degree of V1, right? 3. Degree of V2, 2. Degree of V3, 2. Degree of V4, 3. Can you count total? 3 plus 2, 5. 5 plus 2, 7. 7 plus 3, 10. This total sum is 10. If you want, you can check. This is equal to 2 into number of edges. Number of edges count. How many? 2 into 5. So remember, sum of degrees is equal to 2 into E. This is the formula. Let me write now. Sum of degrees is equal to 2 into number of edges. This is the formula. This is called sum of degrees theorem. This is called sum of degrees theorem. If anyone having any doubt, please let me know. If anyone having small doubt also, please let me know. This is called sum of degrees theorem. Sum of degrees is equal to 2 into E. The technical way of writing, sum means summation, sigma. Sigma I is equal to 1 to n. Sigma I is equal to 1 to n. Degree of Vi is equal to 2 into E. This is the notation. E is the number of edges. Yeah, is it okay till now? Everyone know this. Everyone know this. Sum of degrees is equal to 2 into E. Everyone know. If anyone not okay, please let me know. See, every topic cannot be difficult. Some topics are difficult. Some problems are difficult. Sometimes some topics are difficult. Maybe sometimes some subjects are difficult. Everything will come. Life is like this only. Life is like this only. You cannot expect what is going to be happen. Whatever will come, make it better. Whatever will come, make it better. Right? Like this. I hope you got. Now, one more thing I want to ask you. This graph contain how many vertices? Say this also. This graph contain how many vertices? This graph contain how many vertices? I want answer from you. Vertices how many? Edges how many? Vertices how many? Edges how many? I think vertices are 4, edges are 5. Remember everyone. Edges are increasing. Listen, edges are increasing. I can say size of the graph is increasing. Suppose the vertices are increasing, then we will say, right? Listen. So order of the graph means vertices. Size of the graph means edges. If you want, you can write it. Otherwise, you will forget. At least one thing you remember. You may use in the examination, right? So size of the graph increasing means edges are increasing. Order of the graph is this much means vertices are this much. Remember, size means edges. Size of the graph. That means number of edges. Next one, order of the graph. That means number of vertices. Please take care of this also. Everything I said, sum of degrees theorem I said. First of all, what is the meaning of degree? That is also explained to you. Next one, what is the size of the graph? Size means size of the graph increasing. Oh, edges are increasing. One thing you remember, order of the graph increasing, vertices are increasing. They will say in the problem, sometimes you will say problem like this one. Consider a graph where order of the graph is 25 and the size of the graph is 75. Right? You have to understand. Sometimes he will say vertices, sometimes he will say order of the graph. Sometimes he will say number of edges, sometimes he will say size of the graph. If you don't know these two keywords, you may leave that problem. Now, one more beautiful thing I want to ask you. Please listen everyone. One more small thing, one more beautiful thing I want to ask you. Can you listen this? Can you listen everyone? One more beautiful thing. Can you listen everyone? Everyone listen. Everyone listen. Yeah, fine. See this one. Everyone listen. This graph is a undirected graph. Everyone know. This graph is undirected graph. Everyone know. Suppose if I keep directions. See what will happen. Now, can anyone help me now? What is degree of V1? I want an answer from you. What is the degree of V1? Suppose it is a directed graph. What is the degree of V1? Yeah. Ashwini is saying that. Remember. If at all it is a directed graph, there is no degree. Right now you will see in degree, out degree. How many people are coming inside? How many people are going outside? Can you help me now? For the V3, how many people are coming inside? One person in degree. How many people are going outside? Out degree. So I'm writing now. For the V3 is 1. Right? Positive degree means in degree. In degree. So let me write now. Degree positive. Coming means positive. Degree of V3 means in degree of V3. How much? How many people are coming inside? Coming inside means positive. What is the answer? 1. Right? Let me write now. Degree minus of V3. How many people are going outside? 1. In degree, out degree. Please remember, if at all it is a directed graph, some people are coming inside, some people are going outside. So can you help you know? Can you help you know? What about V4? V4 in degree. How many people are coming inside? 1 person. What about degree minus of V4? How many people are going outside? 2. Right? 2. In the similar way, degree of V2 is equal to 2. Degree of V2 is equal to, let me write it plus. How many people are coming inside? 2. How many people are going outside? No one. So 0. So degree plus. How many people are coming inside? 1. How many people are going outside? 2. Right? Remember, from today onwards, at anywhere if you see in degree, out degree. From today onwards, if you see in degree, out degree, please remember it is a directed graph. In degree, out degree, if you see, please remember it is a in degree, out degree. If you remember at anywhere, if you see in degree, out degree, oh, directed graph. Now, one small question I want to ask you: can you count how many edges in the graph? I want answer from you. Can you count how many edges in the graph? Forget about which side direction. Forget about which side direction. Forget about which side direction. Please count how many edges are there. 5, right? 5 edges are there. Now observe. Now observe clearly. Now observe clearly. See this one. See everyone. See everyone. Sum of in degrees. Careful everyone. Sum of in degrees. How much can you count? Sum of in degrees. Can you count? What are the V1? V1 in degree, V2 in degree, V3 in degree. What are the V1 in degree? 1. What are the V2 in degree? V2 in degree 2. V3 1. V4 1. I think 1 person 1. Right? Sorry, 3 people are 1. 1 person 2. Let me write. So 3 people are 1. 3 people are 1. 1 person 2. Total how much? Total is 5. Am I right or not? This is equal to number of edges. This is equal to number of edges, which is equal to sum of out degree. Check. Sum of out degrees. If you want, you can check. Remember, listen, remember. The reason why I am saying is sum of in degrees is equal to sum of out degrees. Why I am saying is very simple. If you draw one line, listen, if you draw one line, right? For 1 person it is out degree, for 1 person it is in degree. How many out degrees are going? Those many in degrees will come. For 1 person it is out degree, for 1 person it is in degree. How many out degrees will come? Those many in degrees will come. If you want, you can check. Can you go and check? What is the V1 out degree? 2. What is the V2 out degree? 0. What is the V3 out degree? 1. What is the V4 out degree? 2. Check if you want. So sum of in degrees is equal to sum of out degrees is equal to number of edges. Please take care this also. Sum of in degrees is equal to sum of out degrees is equal to total number of edges. That is the reason it became double. Suppose if you remove direction, right? If you remove direction, add these 2 people. If you remove direction, add these 2 people. Sum of in degrees plus sum of out degrees, which is nothing but sum of degrees, which is equal to the double 2e, because 5 plus 5 will become 10. Can be written as 2 into 5, which is e. So be careful. Are you okay till now? Remember, size of the graph increasing. Oh, edges are increasing. Order of the graph increasing. Oh, vertices are increasing. Next one, sum of degrees. When you say degree, no in degree, no out degree. Simply degree. Oh, undirected graph. When you say in degree, out degree, oh, directed graph. Sum of degrees is equal to 2e. This is the formula. Next one, sum of in degrees is equal to sum of out degrees is equal to 2 into number of edges. Yeah, any doubts till now? These are small things. Are Johan, do you have any doubt till now? Gayatri, do you have any doubt? Gayatri, do you have any doubt? Johan, do you have any doubt? Yeah, Aditya Bahuguna. Right, perfect. So now let's move to next one. Right? Because of everything is okay. Let's move to next one. So where is one more person? Yeah, I think one person I forget. Shakir कहाँ पे? Shakir भैया अभी तुम कहाँ पे? Shakir भैया अभी तुम कहाँ पे? Oh, yeah. Okay. चलो. You forgot me. Okay. राज भैया अभी तुम कहाँ पे? राज भैया अभी तुम कहाँ पे? Hayden is there. Okay, fine. Priyoshi, Priyoshi there. Priyoshi, are you there? Priyoshi, are you there? Priyoshi is a Sarvantaryami. Wherever you go, Priyoshi will be there. Priyoshi is Sarvantaryami. Sir, Telugu once. Many times I said Telugu, na? Why you want Telugu? Raz Anna ekkadunnao? It looks so strange to me. After a long time, I am listening this kind of sentence. Raz Anna ekkadunnao? Chalo then. Raz bhai, suno na, right? Are Ashwin, mind your language. Are Ashwin, just mind your language. Chalo then. Please don't divert the topic. Okay, come to the next one. So until now, I didn't done anything. See this one. Graph definition, I said. Next one. Right, listen. Graph definition, I said. That's the first thing. Second one, I said what is the degree. Third one, what is the relation between all the degrees and the number of edges? Sum of degrees is 2e. Can you guess? Why sum of degrees is 2e? What is the reason? Why sum of degrees is 2e? What is the reason? Can you help me now? Every edge count degree 2 or not? Every edge count degree 2 or not? See, if at all it is a edge, this side also 1 degree will come, this side also 1 degree will come. Am I right or not? That is double case. Every edge double will come, because when I say this is the edge, here also one person counted degree, here also one person counted degree. That is the reason double came. Sum of degrees is equal to 2 into e, because every edge will count, every edge will contribute degree 2. If you want, you can write that note. Every edge, I am not saying in degree, I am not saying out degree. Every edge will contribute. Every edge will contribute by degree 2. Every edge will contribute by degree 2. Note. Some people are asking, sir, every edge will contribute by degree 2, you are saying. Suppose it is a directed graph. What is the answer? I don't write at that time, right? So see this one. At that time, I will write like this. Every edge will contribute by in degree 1, by out degree 1, or 1 in degree, 1 out degree. When I say degree, it is a undirected graph. When I say degree, it is an undirected graph. So every edge will contribute by degree 2. Degree means undirected. So when you say undirected, no in degree, no out degree. When you say in degree, then in degree 1, out degree 1. Like that it will come. right? Every edge will contribute by degree 2. You know, you don't have any doubt because, right, because of I'm using degree, so undirected graph. If you want this box also, you can take. These are small things. Can I say like this? Sum of degrees are 2e. Listen, can I say like this one? Sum of degrees are 2 into e. Can I say like this one? Sum of degrees is always even number. Can I say like this? Sum of degrees are always even number. 2 into e means even number. And every time 2 is coming, see, if you take one edge, degree 2 coming. If you take one more edge, degree 2 coming. If every time 2 coming, total sum is even only. Even numbers, if you keep on add, even only will come. Even numbers, if you keep on add, even only will come. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. Even only will come. So I will write that also. Only for namesake, I will write. Only for namesake, I am writing. Sum of degrees. Always even. Sum of degrees always even. When you say degree, remember, it is a undirected graph. Sum of degrees always even. Sum of degrees always even. What is the reason? This is 2 into e. That is the reason. 2 into anything. 2 into anything is even. If you can write any person 2 into something, then it is nothing but even. Sum of degrees always even. Why it is even? 2 into something you return. It should be even. Anyone having doubt? These are small issues. These are small things. Here itself I can write. It is even. Sum of degrees are even. Because of 2 into something. Anything you can write 2 into something. That is even. Right. Now can you help me now? Can I say like this one? Number of edges are always even. Can I say? Number of edges are always even. Can I say or not? You cannot say that. Number of edges are even. You cannot say. See, only I have five edges. Check. I have only 5 edges. There is no relation with the number of edges even. But sum of degrees are 2 into e. Sum of degrees are even. See, sum of degrees is even. Number of edges are not even. Number of edges are not odd. Number of vertices are not even. Number of vertices are not odd. No relation. Sum of degrees are even. Sum of in degrees is equal to sum of out degrees is equal to number of edges. These are small things. Anyone having any doubt, please let me know. As a computer science person, many places you will come across. So please have a look one time. To me, they are very simple because I said many times. See, now everyone is getting graph theory. Now everyone is getting graph theory. So it is like this. Why you live unnecessarily? Because of some little bit difficult one, you cannot live life. One day in your life, some difficult thing came. You cannot. Some people will go for a suicide attempt. Arey man, next day beautiful thing will come, yaar. Today in your life, some serious issue came. Don't go for a suicide attempt. Don't die. Next day, right? Next day morning only some good news will come. Next day morning only some good news will come. At that time, you may not be available. Some people with short temper, right? Small things only. Can I die? Right? Dying is something like a tourist place or what? Small problem can every problems are coming. Can I die? Is it tourist place? Right? If you go, if you go, you cannot come. It is not a park to go and come. People, right? 5 minutes they will cry, they will leave. You may be thinking that my mama, papa will cry lifelong, sir. Ready, sir? If I die, my mama, papa will cry lifelong. No, yeah, maximum 5 days. Just they will do acting. Ayyo, my son, like this. After 1 week, normal. Because they also know that, right? Their son cannot come back. Their daughter cannot come back. So please don't do these kind of things. Everyone having problems. You have problem, I have problem. See, Modi ji having problem. Modi ji seriously having problem. You don't know whether he will come back or not. Rahul Gandhi having serious problem. You don't know whether he will win or not. He is, I think, from long time. He is dancing on the right. He is dancing on roads only. Rahul Gandhi dancing long time, from long time, he is dancing on the road. Kejriwal is there in the jail until yesterday. Until yesterday, he is there in the jail. Today, he went to once again jail, saying that whenever once again, other than BJP government will come, right, I will come back. He said like this and I went. So what I mean to say is, problems are part of life. By seeing small problem, don't cry. Right? Suppose DMS, one problem troubling. Don't worry. Try a little bit. We all are there to help you. We all are there to help you. Yeah. Someone is posted something. You want to say that you are diverting. Please, can you read my doubt? Okay, I'm reading. Sir, one doubt. Suppose odd number of vertices are having odd degrees. Odd number of vertices are having odd degrees. Does it hold this property? Means sum of degrees? You do anything. Not odd degree, not even degree. Do anything. Sum of degrees are even. Sum of degrees are even. Can anyone help you? What is the reason? Sum of degrees are even. Because sum of degrees is 2e. 2 into e, definitely even number. You do anything. Do whatever you want. Because 2 into something. Right? Fine. Yeah, I think someone is mentioned, never possible all odd degree and all. Yeah, we will see anyhow. Sayan, I don't want to talk all these things. Right? Sayan Bhaiya, I cannot talk. If I talk, people will ask, why not? You will see afterwards anyhow. Right? You will see anyhow, right? Just I simply ignored by saying one small line. Please verify if you want. If I talk more, people will confuse. And are you comfortable till now? So remember, everyone remember, problems are part of life. Right? Don't worry at all. Right? Don't cry. Oh, problem came. Oh, tomorrow maybe solution will come. Day after tomorrow maybe solution will come. You have to think like this. You have to think like, no need to leave it. No need to cry. If possible, post in the group. Ask your friends. Take help and grow. Right? Fine. Perfect. Until now, everything is okay. Now come to next. Everyone listen. Come to next. Everyone observe. Come to next. V1, V2, V3, V4. V1, V2, V3, V4. These are the 4 vertices. Observe what I want to say. Just observe. Yeah. Let me help you now. In this graph, whatever graph I draw, let me do the same thing once again. V1, V2, V3, V4. V1, V2, V3, V4. Same diagram I drawn again. Now listen, can you help now? Left diagram, right diagram. Left diagram, right diagram. Who is having cycle? Left diagram, right diagram. Who is having cycle? Cycle I am asking. Any cycle? Both are having? Yeah, I am not asking self loop. Who is having cycle? Both are having. Right? Both are having cycle. Now listen. Both are having cycle, that's fine. Listen everyone. Both are having cycle, that's fine. If I keep like this is called self loop. Cycle there, self cycle. Or self loop. Right? So, but if you see the right side, right, loop is not there. Self loop is not there. Loop there, but self loop is not there. Left side diagram, right, self loop is there. Right side diagram, there is no self loop. And one more thing. Can you help me now? Between 1, 3, listen, between V1 and V3 edge there, if I keep one more edge, these are called parallel edges. This edge and this edge both are called parallel edges. These are called parallel edges. These are called parallel edges. So remember in this graph, parallel edges are not there. Remember everyone, a graph who don't have self loop and who don't have parallel edges, these two things not there. Let me write now. Self loop not there. End operator. Parallel edges also not there. A graph which don't have these two things, no self loop, no parallel edges. That graph is known as simple graph. Very simple. Unnecessary things not there. That graph is known as simple graph. A graph which having right, self loop may be there, parallel edges, any one may be there, or both are there. So let's see. Self loop may be there. Self loop may be there, R operator. Parallel edges may be there. When you say R operator, any one. That is called as, right, multigraph. This is called multigraph. Multi means unnecessary. See this one? Already one there, one more edge Y. That is called multigraph. Already one edge there, why one more edge unnecessarily? So that is called multigraph. Right? One edge there, one more edge not allowed between two people. That is called simple graph. That is called simple graph. Yeah, because of you are little bit okay. Simple graph and multigraph little bit okay. Now I will ask one question. Please give answer. Now I will ask one question. Please listen. Please listen. In n vertex simple graph, everyone observe, in n vertex simple graph, what is the maximum degree of any vertex? In n vertex simple graph, maximum degree of any vertex possible. Can anyone guess? In n vertex simple graph, maximum degree of any vertex possible. Minimum degree of any vertex possible. What is the answer? If anyone knows. In n vertex simple graph, maximum degree of any vertex possible. Minimum degree of any vertex possible. Right? Let's see. Let's see here. So when you say simple graph, listen, when you say simple graph, self loop is not allowed. Parallel edges also not allowed. Let me remove this. Let me remove this one. Self loop is not allowed. Parallel edges also not allowed. Okay. Now he's asking four vertex, right? Four vertex simple graph, maximum degree of any vertex possible. How much? Let us assume I want to keep maximum degree. What is the answer? Right? Total people are 4 people. I want to keep maximum degree to him. I think he is adjacent to all other people. He is adjacent to V3, he is adjacent to V2, he is adjacent to V4 also. But one thing, he cannot be adjacent to himself. If at all he is adjacent to himself, self loop. So 4 vertices, maximum degree of any vertex possible in the simple graph is 4 minus 1, 3. I think here n minus 1. In n vertex simple graph, maximum degree of any vertex possible is n minus 1. Maximum degree of any vertex possible. Think about maximum. Oh, next one. Can you guess? Can you guess? What is the minimum degree possible? In n vertex simple graph, what is the minimum degree possible? Let us enter one more vertex. He may not adjacent to anyone. Minimum degree 1. Sorry, minimum degree 0. Because he is not adjacent to anyone. It is not necessary everyone is adjacent to at least to someone. It is not guaranteed. It is not guaranteed. V5 and other people, no connection. So minimum degree possible in n vertex simple graph is going to be 0. Maximum is n minus 1. Will you agree with this? Will you agree with this? Someone is saying 1 maximum and minimum 0. No. Maximum is V minus 1. If at all 4 people, maximum possible 3. Minimum is 0. Because, right, V5 may not be adjacent to anyone. Right? Fine. Are you comfortable? Check, small doubts are there. Please rectify. Please rectify. See, every day you have to gain something. See, don't gain bad things in brain. Don't keep dust in the brain. Right? Every day move forward. Every day gain something. Don't keep the negative things every day in brain. So some people, early morning they woke up. They will do this only. I cannot do this. I cannot do. If you keep on saying, right, I cannot, right? You know, right? God is keep on listening. Whatever you are saying, God is keep on listening. Every day you are saying, I cannot. God will think, oh, maybe you don't want. He will say, okay. Just God is moving like this. In front of you, God is moving. Because of God is everywhere, you cannot see. God is everywhere, but you are a human, you cannot see. But God is keep on moving like this. You are saying, I cannot, I cannot, I cannot. God will listen. Oh, you don't want. Okay, okay, Bhaiya, yes. Right? By saying yes, he will go, you cannot. So don't say every time I cannot, I cannot. Don't say this. Right? If at all really difficult, take help. Ask friends. Keep on increase the knowledge, keep on improve. Who is God here? No one is God. No one is God. So n vertex simple graph, maximum degree is n minus 1, minimum degree 0. Will you agree with this? I'm talking about simple graph only, not multi-graph. Some people are asking, sir, how can you say that maximum is n minus 1? I can take self loop, na? No, Bhaiya. Simple graph self loop is not allowed. Sir, I can take parallel edges, na? Simple graph parallel edges also not allowed. In n vertex simple graph, maximum degree of any vertex is n minus 1, minimum degree 0. Some people are asking, so sir, if that is the case, what about multi-graph? Let me write that also. In n vertex multi-graph, in n vertex multi-graph, maximum degree of any vertex possible. Minimum degree of any vertex possible. So what is the answer? In n vertex multi-graph, maximum degree of any vertex possible, minimum degree of any vertex possible. So what is the answer you are thinking? Minimum, I think minimum 0. Remember, it is a multi-graph. He may not be adjacent to anyone. Minimum degree 0, I will accept. Can you say maximum how much? Remember, total vertices are n. Total vertices are n. Remember, total vertices are n. Let us assume n value 4. Total vertices are 4. In 4 vertex multigraph, what is the maximum degree possible for any vertex? I will try. Can you see this one? I will try. 4 vertex multigraph for a particular vertex, what is the maximum degree? Let's see. 1, 2, 3. I want maximum. 3 over already. Listen, 3 over already. Everyone listen. Degree 1, degree 2, degree 3. That is fine. See the interesting answer. Degree 1, degree 2, degree 3, degree 4, degree 5. Because you will count this also, you will count this also. Remember self degree. Listen, self loop will count degree by 2. Self loop will count degree by 2. I am writing here. Self loop, because he will count this also. You may say y is counting 2 times, right? So he cannot see. Computer cannot see. Computer will simply say, okay, this is 1, this is 1. Similar way, this is 1, this is 1, this is 1. So self loop will count degree by 2, remember. So degree 1, degree 2, degree 3, degree 4, degree 5. Now see the answer. Degree 6, degree 7, degree 8. Because when you say parallel edge, I can write many times. There is no ending. So what is the answer? Infinite. Maximum degree possible for any vertex is infinite, means undefined. It may be 10 also, it may be 1 lakh also. Someone is saying degree is equal to number of adjacent, or degree is equal to number of edges. So number of people adjacent to me. So the thing is, right, hidden you see this one. So he will think that this person also adjacent. This person also adjacent. Or if you want, you can say number of edges. If you want, you can count. Yeah, you can change it because he is having clear problem. You can change it if you want. Right? Degree of any vertex is nothing but the number of edges associated with that person. Degree of V1 is nothing but number of, right? Here there is some difference came. That's the reason Hayden is asking. Here, sir, here not vertex, na? Here edges, na? Right? The number of edges, but here also 1 edge only. The number of edges associated. If you see Hayden, this is 1 edge only, na? This is 1 edge only, right? So, but anyhow, right? Because of self loop, it is a special person. He will count that side also. He will count this side also. Please careful. Yeah, someone is saying parallel edges. See, what is the meaning of parallel edge? Between two people already edge there. Between two people already edge there. If you keep one more edge, that is called parallel edge. Between two people already edge there, you are keeping one more edge. That is called parallel edge. That is called parallel edge. So I think when you say one, this is a parallel edge, this is also parallel. This is also parallel. This is also parallel. So a particular person having, in the case of multigraph, right, infinite degree. So n vertex multigraph, maximum degree of any vertex is infinite, minimum degree of any vertex is 0. Next one, right? So for the vertex V1, see one, for the vertex 1, how many people are adjacent? How many people are adjacent? Or how many edges are incident with this? How many edges are belongs to with V1? Right? The number of edges associated with V1, that is also similar. But when you come here, the number of edges associated to V1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, you may say that it is a one edge. Count both the sides because you don't know that same person is coming back. Meaning wise similar, right? Hidden meaning wise similar. Yeah, fine. Whatever is going on, please go as usual. Right? Don't push me because they will come next. Hidden, if you take any way, similar answer. Right? Whatever way you want, you can write. I'm repeating once again. Degree of a particular vertex is nothing but the number of vertices, right, adjacent to him. That's the one way. One more way. The number of edges associated with that vertex. The number of edges associated with that vertex. So for the vertex 1, the number of edges associated 1, 2. If self loop is there, this also. You may say same edge, but he is a special person. Let me write now. Self loop will add degree 2. Self loop will add degree 2. Perfect. Anyone having any objection till now? Every point take care. Small doubt also there, you can ask me. If at all possible, if at all now only it is related, I will explain. If not, I will say further it will come. In multigraph, number of vertices and the number of edges relation. Right? You will see if any relation there, you will see that. Are you comfortable here? Degree. Remember, see from this entire discussion, I want to say, right? Graphs are two types. Everyone listen. Graphs are two types. Right? Simple graph, multigraph. Multigraph contain unnecessary stuff. Multigraph contain unnecessary stuff. What is that? Self loop is unnecessary. Parallel edge is also unnecessary. Some extra there, multigraph. Nothing extra, simple graph. So n vertex simple graph, When you say n vertex simple graph, self loop not there, parallel edge is also not there. Right? So both are not allowed. Suppose any one there or both are there, that is called multigraph. Now come here. N vertex simple graph, maximum degree of any vertex is n-1, minimum is 0. N vertex multigraph, maximum degree of any vertex possible is infinite, minimum degree is going to be 0. Any doubts till now? Priyosh is saying, can there be many self loop? Maybe. There is no relation, right? How many? Every vertex can have. Priyoshi, every vertex can have. Fine. Some may not be there also. Right? Any number of can be there. For same vertex. Yeah, maybe. Because there is a, right? So I think Priyoshi is saying that for one person, more than one self loop possible because of parallel edges may be possible. Right? So Priyoshi, are you getting? Priyoshi, are you getting? When you say parallel edges, right? One self loop is there. One more self loop you can keep. Yeah, means whatever it is, parallel self loop, non-parallel self, whatever it is, self loop, multiple possible or not. See, one person already like this. Because the parallel edges are allowed, maybe you can keep one more also, no problem. Maybe you can keep one more also, no problem. Yeah, but anyhow, they are not useful. Because of your asking, I am saying. Because of your asking, I am saying, but there is no use. We call them parallel self loop, nothing. See, first of all, she asked some unnecessary question. For that you are adding some more. It is almost like adding fire, right? Adding oil to the fire. You are adding the petrol to the fire. Already fire going on. Add petrol also. Then it will become more fire. Fine. Can we move? Yeah, see, Priyoshi, whatever you said, multiple self loops may be possible because of parallel edges. That is the final conclusion. Abhi, are you okay? Yeah, I think Johan asking something, I will go for that also. Johan asking something, I will go for that also. Can I move further? Arey, Abhi, can I move further? Abhi, whatever you are saying, that may be correct also, but anyhow not required, so I am not concentrating. Right? Anyhow, it is not required, so I am not concentrating. Right? Now come to the next one. You may be correct also, Abhi. I am not sure about that because it is not required. I didn't done any discussion on that. Now come here. One more thing. Please listen, everyone. Please listen, everyone. V1, V2, V3, V4. Yeah. Can you help graph definition, combination of vertices edges or not? Graph definition, combination of vertices edges or not? Graph definition, combination of vertices and edges. Of course, see, are they connected or not? Who cares? Sir, between V1 and V2, no edge there. Who cares? Yeah. Sir, between V1, V2 and V3, no edge there. Who cares? But what is the definition? Combination of vertices edges. It is a graph. Sir, how can you say he is not connected to anyone? In the graph definition where he mentioned, everyone should be connected. In the graph definition where he mentioned, graph is combination of V and E. Graph may be connected, graph may not be connected. No relation. Graph may be connected, may not be connected. No relation. Right? Hidden. Sorry. Johan, you got. Graph may be connected, may not be connected. Who knows? Graph may be connected, may not be connected. Who knows? It may be, may not. Because in the definition, nowhere he mentioned. Fine. Can we move to next? Yeah. So because of you are really comfortable, can you see the next one? So can you see the definition for simple graph one more time? Can you see the definition for simple graph? No self loop, no parallel edges. If anything extra, multigraph. If nothing extra, see, self loop is unnecessary. Parallel edges also unnecessary. If nothing extra, unnecessary, that is called simple graph. If something unnecessary, so that is called multigraph. Now our discussion. Careful, everyone. Our discussion now. Only simple graph. Write down. Our discussion only simple graphs. Our discussion is only simple graph. We will discuss only simple graph. Yeah. Now everyone have to listen. Everyone. Simple graph means what? You know very well. Simple graph means what? Self loop not allowed. Parallel edges not allowed. Everyone know. That is the reason I written the shortcut and AND operator. Both cannot be there. Both cannot be there. Careful. Only for namesake I written because you are already know. You already know, so namesake I written. So someone sees someone, right? Before the class, one person is blackmailing me, saying that you said that you will give notes, you are not given. You said that you will give notes, you are not given. Arey bhaiya, if I give notes also, what is the use? What is the SL? SL means Sri Lanka. What is the PE? PE means Pakistan. What is SL? What is PE? Bhaiya, I given notes. What do you do, man? You keep my notes in the museum or what? What is SL? You will ask me, you will blackmail me. What is SL? What is PE? And you will ask me one more thing. How can you write like this? Arey bhaiya, it's my notes, my wish. What is your problem? Right? It's my notes, my wish. You keep on torturing after sending my notes. You don't read also. You will keep on torture me. Finally, I will send my notes. You don't read also. I will ask after some time, are you reading? Arey, kya notes here? What kind of notes it is? You will blackmail me further. So that is the reason I am not giving. He is not understanding. He is not understanding. Now come everyone. Come everyone now. Everyone come. Everyone come here. Please see this. Everything done. We done very good work till now. Can you see this? A, B, C, D. A, B, C, D. A, B, C, D. Everyone observe. A, B, C. Yeah. So just I want to ask you one small line. Just I want to ask you one small line. 5 vertex graph. A graph contains 5 vertices. A graph contains 5 vertices. In the simple graph, what is the maximum degree possible for any vertex? A graph contains 5 vertices. In the simple graph, what is the maximum degree possible for any vertex? Yeah, can you say the number? A graph contains 5 vertices. What is the maximum degree possible for any vertex? But remember, it is a simple graph. I think people are saying that, sir, he cannot be adjacent to other people. He cannot be adjacent to himself, but he can be adjacent to other people. I think total people are 5 people. Other people are 4 people. So he is adjacent to other 4 people. See this one? 1, 2, 3. He is adjacent to all other 4 people. Let us assume he also adjacent to all other 4 people. Let us assume that E also adjacent to all other 4 people. So in the given simple graph, every person is adjacent to every other person. Then that graph is called complete graph. This is a complete graph with 5 vertices. This is called K5. K5 means complete graph with 5 vertices. Complete graph with 5 vertices. K means complete with 5 vertices. Some people are asking, sir, what is the meaning of K5, sir? K5 means complete graph with 5 vertices. What is the meaning? 5 vertices are there. Every person contain maximum degree. Because of it is a simple graph. Maximum degree 4. Everyone contain 4. This is called complete graph with 5 vertices, K5. Shortcut is K5. This is the, listen everyone now, 3 vertices. Maximum degree possible 2. Everyone having degree 2. It is a K3. Complete graph with 3 vertices. Now next one, 4 vertices. Every person degree is right, maximum 3. Maximum 3. This is called K4. Complete graph with 4 vertices. What I want to say is, in the given simple graph, every person contains maximum degree. That is called complete graph. In the given simple graph, every person contains maximum degree. That is called complete graph. Complete graph with n vertices will be represented as Kn. Complete graph with n vertices will be represented as Kn. Some people are asking, Kn contain how many edges are? Can you see this one? Number of edges. Everyone observe. Number of edges. Number of edges present in K5 is equal to number of edges present in K5 is equal to, very interesting, very interesting. How many people will give the answer to me? K5 means how many vertices? Very interesting answer. K5 means how many vertices? K5 means how many vertices? K5 means how many vertices? 5. Doesn't everyone know? K5 means 5 vertices, but every vertex degree 4. See this one. First person degree 4. Second person degree 4. Third person degree 4. Every person degree maximum. 5 people are there. Every person degree is 4. So I think this one, if you observe, right? See this one. 5 people are there. Every person degree 4. Everyone know repetitive addition is multiplication. I think 5 times everyone is 4. 5 4s 20. Remember, this is sum of degrees. Doesn't everyone know this is sum of degrees? Am I right or wrong? This is sum of degrees. Am I right or wrong? This is sum of degrees. Am I right or wrong? Some people are saying yes, right, sir. Sum of degrees means I think 2 into e. This is sum of degrees. Right or wrong? Yes, that means sum of degrees are 2 into e. But I want e because I want number of edges. I want e. Divide by 2. Divide by 2. Then I think 20 by 2. 10. 10 edges are there. Count. Sum of degrees are 2 into e. Right? But I want edges. So by 2 you do 2 cancel. E will come. So number of edges became 10. So if anyone having still doubt, let me go a little more better way. See this one. Number of edges easily will get now. Number of edges possible. Careful. In K10 is equal to, see the easiest way. Number of edges possible in K10 is equal to, what is the answer? I think 9, 9, 9, 9, 9, 10 times. So 10 people, every 1 degree is 9. But this is sum of degrees, which is nothing but this is the 2e. But I want e, divide by 2. So I think 90 by 2, 45. 45 edges are 10 people, every person degree 9, 9, 9. So sum of degrees it is. Sum of degrees means 2e, but I want e, just do by 2. 45. Now because of you are little more okay, can you see this one? Number of edges possible. See this one. Number of edges possible in Kn, complete graph with n vertices is equal to, I think n people are there. Every person degree n minus 1. But remember, it is the sum of degrees means 2e. But you want e, divide by 2. This is the formula. Number of edges possible in Kn is equal to n into n minus 1 by 2. Some people are asking, sir, complete graph definition, sir. Complete graph definition, very simple. Complete graph Kn is nothing but, in the n vertex graph, every person contains maximum degree. In the n vertex simple graph, every person contains degree n minus 1. Then it is called complete graph with n vertices, which is called Kn. I am repeating once again. Complete graph Kn is nothing but, in the n vertex simple graph, every person contains degree n minus 1. Then it is called as complete graph with n vertices. Then how many edges are there? This is the way of calculation. This is the way of calculation. Are you comfortable? Are you comfortable? Remember, we are discussing about only simple graphs. We are discussing about only simple graphs. We are discussing about only simple graph. One of the simple graph is complete graph. Are you comfortable? Some people are asking, sir, how many edges are here? Number of edges in K4 is nothing but. Number of edges in K4 is nothing but. What is the answer? 4 people. Every person degree 3. Right? But this will give sum of degrees 2e. This will give 2e. By 2 you do. Right? I think 12 by 2, 6 will be there. 6 edges count. 1, 2, 3, 4, 5, and 6. Is it okay? If you forget also, you can bring it out. Please don't by heart. If you forget also, you can bring it out. Take one example and check. Trust me, I don't know anyone. Either mathematical logic or TOC or algo or data structure. I don't have any idea. Before your class, I will think what will be the yesterday I taught. Oh, yesterday here. So next one is this. Next one is this. So that's how I planned, right? So the only thing, if I have doubt, I will take one example and I will check. If I have doubt, I will take one example and I will check. I think one more interesting answer. One more. Array man, very simple. Complete means complete. Complete means complete. Now, can anyone help you now? Listen everyone now. Is it complete graph? Very interesting question. Very less people will give answer. If you want, you can check. If you want, you can check. Very less people will give the answer. Is it complete graph? Is it complete graph? If anyone say yes, one more question. Is complete graph is a simple graph? Is complete graph is a simple graph? When you say it is a complete graph, okay. Next one. Is it simple graph? Yes. Listen everyone now. Complete graph, which is a simple graph. See, if you add one more edge inside, it will become a multi-graph. That is the reason it is a complete. Is already maximum. You cannot add one more edge. Add one more. It became a parallel edge. Add one more, it will become a parallel edge. See, already between these two people, edge there, you kept one more edge. It is already complete, yeah. Where will you keep one more? If you keep one more, it is no more simple graph. It will become a multi-graph. Complete means already complete. Don't keep one more extra. If you keep one more extra, it is no more simple graph. It will become a multi-graph. Now, it is a very, very important one. In all simple graph, which simple graph is the larger one? In all simple graph, which simple graph is a larger? Complete graph is the maximal one. Some people are asking, sir, can I add one more edge? Add one more. It is no more simple graph. Add one more edge. It is no more simple graph. In all simple graph, it is the largest graph. Complete graph is the largest simple graph. Complete graph is the largest simple graph. Means in all simple graph is the largest one. Some people are asking, how can you say largest? I will add one more edge, then it is no more simple graph. In all simple graph, largest one is complete graph. Remember, because everywhere I kept maximum edges. That's the reason it is already maximum. If you add one more edge, it is no more simple graph. Now come to one more interesting answer. Can you see this? Can you see this also? A, B, C, D. Yeah. Now listen. Is it simple graph? Is first graph is simple graph? Is first graph is simple graph? Yes, it is a simple graph. Is second graph is a simple graph? Yes, it is a simple graph. Remember. Listen everyone now, remember. In the given simple graph, every person contain, I'm repeating once again. In the given simple graph, every person contain minimum degree 0. In the given simple graph, every person contain minimum degree. Then that graph is called null graph. It is a 4-vertex null graph. Null graph means 0 edges. In the given simple graph, every person contain minimum degree. Then that graph is called null graph. This null graph contains 4 vertices. 4-vertex null graph. Remember, this is also null graph. 3-vertex null graph. Null graph means 0 edges. Vertices we don't know. So you have to say vertices. Null graph means edges 0. How many vertices? I don't know. So you have to say 3-vertex null graph. Oh, 3 vertices where number of edges are 0. 4-vertex null graph. Oh, 4 vertices, number of edges 0. Remember, in all simple graph, smallest simple graph is null graph. In all simple graph, smallest simple graph is null graph. Remember, null graph contains 0 edges. Vertices we don't know, so they will say in the exam. They will say, listen everyone, 100 vertex null graph, how many vertices? 100 vertex null graph, how many vertices? He will say vertices. 100 vertex null graph, how many vertices? Array man, what I'm asking, again I'm repeating. 100 vertex null graph. How many vertices? 100. How many edges? 0 edges. Null graph means 0 edges. Vertices they will say. And one more, some people are asking, can you see this one? Some people are asking, sir, 5 vertices complete graph contain how many edges? Sir, 5 vertices complete graph contain how many edges, sir? Like this, 5 into 4 by 2. 5 into 4 is sum of degrees, means 2e by 2. So only e will come. So 10. Next one. 10 vertices complete graph, how many edges are there? 45. Next one, n vertex complete graph, how many edges are? N into n minus 1 by 2. Similar way, 4 vertex null graph, how many edges? 0 edges, but vertices how many? 4. Next one, 3 vertex null graph, how many edges? 0. Then how many vertices? 3. Next one, null graph, 0 edges are confirmed. Vertices can be anything. Whatever you want, you can take. Right? So I will write here if you want. N vertex null graph contain 0 edges and n vertices. In the given simple graph, every person contains minimum degree. In the given simple graph, every person contains minimum degree. So null graph. In the given simple graph, every person contains maximum degree. Complete graph. Can I help you now? In all simple graph, who is the hero? In all simple graph, who is the hero? In all simple graph, who is the hero? Complete graph, who is the villain? In all simple graph, who is the hero? Complete graph, who is the villain? Null graph. Two extreme corners. Yeah, people thought that, okay, Reddy sir said hero, next one heroine. No bhaiya, no relation. Hero and heroine both are same. Hero and heroine both are same, right? In the hero, right, leading character, in the boy's leading character is hero, in the girl's leading character is heroine. They both are same, bhaiya. They both are same. Yeah, again I'm repeating. In all simple graph, largest one is complete, smallest one is null. Forget about what he says. So everyone, as I mentioned to you starting, size of the graph is larger. Graph contain more size, means more edges. Graph contain less size, means less edges. That's how I decided. So again I'm repeating now. In all simple graph, largest simple graph means size of the graph is more. What is the answer? Complete graph. Smallest, right? Simple graph, null graph. These are the two extreme corners. Null graph is the smallest one. Complete graph is the largest one. Is it okay? These are normal. Everyone know this. Whatever I discussed, everyone know. Only for namesake I said. Because of you people are very good. Listen, I will ask one question. If you want, you can check. Everyone will give wrong answer. If you want, you can check. Within few minutes, I am asking one question. If you want, you can verify. Everyone will give wrong answer. Let me try. Be ready. You will give wrong answer. If you want, you can check. In 10 vertex, simple graph. Maximum how many edges? Minimum how many edges? I want answer. In 10 vertex simple graph, minimum edges how many? Maximum edges how many? I want answer. Calculate properly. Don't say whatever way you like. In 10 vertex simple graph, minimum edges how many? Maximum edges how many? Everyone know. 10 vertex simple graph, minimum. Oh, I want maximum edges. Oh, complete graph. What is the answer? I think it is nothing but number of edges in K10. number of edges in K10, which is going to be, I think, someone is mentioned 10 into 9, 90 by 2, 45. Next one, minimum edges how many? Oh, what is the number of edges in null graph, right? Null graph with 10 vertices. Null graph with 10 vertices, right? Which is going to be 0 edges. Yeah, because of your okay, I think everyone is given answer. Now I am asking, very interesting. This is a very interesting. Can you give answer? In this one, in 10 vertex, complete graph. In 10 vertex, complete graph. In 10 vertex, complete graph. Yeah. Maximum edges how many? Minimum edges how many? Can you give answer for this? In 10 vertex complete graph, maximum edges how many? Minimum edges how many? Can you give answer properly? In 10 vertex complete graph, maximum how many? Minimum how many? Someone is saying minimum infinite, maximum. Array, minimum infinite, how maximum 45? Yeah. Don't you have common sense? Array, Gootle, don't you have common sense? He is saying minimum 45, maximum infinite. Array, Ashwini, more than 45 if you keep, it is no more simple graph. It is no more simple graph, na? First of all, complete graph is a simple graph. Self loops are not allowed. Parallel edges are not allowed. So what is the answer? Remember here. 10 vertex complete graph. It is already complete. Already is having maximum. What is maximum? What is the minimum? Both are 45. It's a complete graph. Yeah. From the complete graph, delete one edge also. It is not complete. For the complete graph, add one more edge also. It is not simple graph. You cannot add, you cannot delete. That is the reason I said to you, you may give wrong answer, be careful. In 10 vertex complete graph, he already mentioned it's a complete. Complete, already having complete. What is the minimum, what is the maximum? See, whenever I will say simple graph, you may get a maximum, you may get a minimum. But when you say complete graph, what is max, what is min? Complete itself is max. Everything is itself only. Everything is itself only. Fine. Anyone done wrong, rectify. I know that you will give wrong answer. If anyone done wrong, I know. I said before only. Sir, simple graph can be directed or undirected. Yeah. See, if at all no self loop, no parallel edges. Are you getting? No self loop, no parallel edges, right? Then it is going to be a simple graph. But anyhow, right, Johan, in the examination, they will clearly mention. Don't worry. In the exam, they will mention clearly. Consider a undirected simple graph. They will give problem like that. Undirected only. Whatever I am discussing here, undirected only. If you want, I will write also. Let's go back and I will write. Undirected. You will mention in the problem. Don't worry. It may be directed also, but I written undirected. I am going to discuss only for undirected. If you okay, can I move to next line? Yeah, same thing I can ask one more way also. Can you see this one? In n vertex, null graph. In n vertex null graph, maximum edges how many? It is a trap. Array, it's already null. What is maximum? What is the minimum? Yeah, 0. It is a trap. These are traps. Can you help me now? This maximum and minimum, interesting when? This maximum and minimum interesting when? Null graph or complete graph or simple graph? This maximum minimum interesting. This maximum minimum interesting. Complete graph or complete graph or null graph or simple graph? Simple graph. Simple graph. Simple graph having 2 dimensions. See, simple graph. Simple graph means no self loop, no parallel edges. You draw whatever way you want. If you keep everywhere more edges, maximum will come. If you keep everywhere less edges, minimum will come. This is only interesting. Remaining things are fixed. Complete means full yaar. Null means nothing yaar. Null means nothing. Complete means everything. Okay, are you okay? Are you okay till now? Are you okay till now? Yeah, perfect. Perfect. You are okay till now. You are okay till now. See this. You are okay till now. Everyone observe this also. See this. A, B, C, D, A, B, C, D, A, B, C, D. A, B, C, D. Yeah. Now listen. Now listen everyone. Now listen everyone. See this one. In this graph, every person degree equal. In the first graph, every person degree equal. Here also every person degree equal. Here also every person degree equal. Here also every person degree equal. Remember, in the given graph, every person degree equal. That is called regular graph. That graph is called regular graph. Every person degree equal. Regular graph. This is also regular graph. This is also regular graph. This is also regular graph. In the given graph, every person degree equal. Then that graph is called regular graph. But every person degree equal, that is 3. That is called 3 regular graph. It is a 2 regular graph. It is 1 regular graph. It is a 0 regular graph. Remember. In the given graph, every person degree equal. Then it's called regular graph. Every person degree 3, so 3 regular graph. Every person degree 2, so 2 regular graph. Every person degree 1, 1 regular graph. Every person degree 0, 0 regular graph. Now listen. Now listen everyone. Here 4 people are there. See, 4 vertices, but it is 4 vertex, 3 regular graph. Let me write now. 4 vertex, 3 regular graph. What is the meaning? 4 vertex, 3 regular graph means everyone degree 3, 3, 3, 3, 3, 4 times. Right? So 4 people, every person degree 3. This is sum of degrees. By 2 you do. Number of edges you will get. In the similar way, if anyone having doubt, can you see here? This is also 4 vertex 2 regular graph. That means 4 people there, every person degree 2. What is the meaning? 2 plus 2 plus 2 plus 4 times. So 4 people, every person degree 2. This is sum of degrees. By 2 you do. Number of edges you will get. So 4 into 2 by 2, 2, 2 cancel, 4, check. Next one, 4 into 3, 12 by 2, 6. If you want, you can verify. In the similar way, can you come here? There are 4 vertices, every vertex degree is 1. 4 vertices, 1 regular graph. That means 1 plus 1 plus 1 plus 4 times. There are 4 people, every person degree 1. This is sum of degrees. Do by 2, number of edges will come. So 2 edges. Similar way here also. Right? So 4 people, every degree 0. By 2 you do. So if you really comfortable, whatever I discussed, can you see this? Can you see this? N vertex, N vertex, K regular graph, N vertex, K regular graph contain how many edges? Contain edges. Very simple story. What is the answer? N people. Every person degree K. This is the sum of degrees by 2. Nk by 2. That's it. Please don't by heart. If you by heart, no use. If you by heart, no use. Right? Take one example and check. Yeah, one more interesting answer. One more interesting answer. See this one. See everyone. See everyone. This is not complete graph, but regular graph. Listen everyone now. This is not complete graph, but regular graph. This is not null graph, regular graph. Right? Remember, some people are asking one more interesting answer. Sir, this is K4. But of course, it is a K4. K4, another name is 3 regular graph. 4 vertex, 3 regular graph. K4, another name is 4 vertex, 3 regular graph. But remember, it is not neither K4, not null graph. It is not a complete graph, neither null graph also. See this one. It is a 4 vertex null graph. Maybe some regular graphs are complete graphs. Some regular graphs may be null graph. Whatever it is. Right? Whatever it is. Don't worry about the relations, but learn what is the meaning of regular graph. Don't worry about relations. Don't worry about relations. Some people are asking, sir, what is the meaning of regular graph? Very simple. In the given graph, every vertex degree same. In the given graph, every person degree same. Then it is called regular graph. Not only same, how much? 1. So 1 regular graph. Not only same, 2. Everyone 2 regular graph. Not only same, everyone 3. So 3 regular graph. Not only same, everyone K. So K regular graph. That is answer. Yeah. See? Fine? Is it fine? Is it fine? So that's the reason I already said, I already written simple graph. I am discussing simple graphs only because in exam simple graphs only there. If you see in the previous paper at anywhere multigraph, please let me know. Right? Johan, there is no ending. See, multigraph, complete graph. Where is the ending? Yeah, maximum degree infinite. Where I will keep maximum degree infinite. What is the meaning of complete? For everyone, I will keep infinite or what? For every person, I will give infinite. I written very clearly on the top. Simple graphs, I am discussing only simple graph because if I go to multigraph, answer become infinite. If I go to multigraph, answer become infinite. Fine? If I go to multigraph, answer become infinite. See, multigraph, listen, multigraph. If I do regular graph, infinite edges. Because maximum degree may be infinite, who knows? So to make things easy, just simply write simple graph and undirected. Right? If at all anything you will ask extra, we will see the previous paper. Unnecessary discussion, what should I do? That is the reason I am experienced. If I am not experienced, listen, if I am not experienced, you take my car, take that side, I will go. After 1 month, I got, I came to wrong place. If I am inexperienced, take my hair, drag me down. After 5 days, right? So you try your level best to push me either this side or that side. You push me. I will just throw all the people. I will stay here. I will just throw all the people. I will stay here. Someone is asking, simple graphs are called regular graph. Can you help me now? Every simple graph is regular graph. How can you ask like this? How can you ask like this? See, simple graphs are many types. See, some simple graphs are null graphs, some simple graphs are complete graphs, some simple graphs are regular graph. See, every regular graph is simple graph, but every simple graph is not regular. Reverse. Every regular graph is simple graph, but every simple graph need not be regular. Can you help me now? Regular graph and simple graph, which is a superset. Regular graph and simple graph, which is a superset. Simple graph is superset. We are discussing simple graphs. Inside simple graphs, some partitioning is going on. Some simple graphs are complete. Some simple graphs are null. Some simple graphs are regular graphs. Right? Remember for everyone formula. Don't in the by-hearted manner. Meaningfully remember. Don't by heart. If you by heart, no use. If you by heart any subject of computer science, if you by heart, no use. One or two, unknowingly, one or two maybe you have to by heart. 99% without by hearting study. 99% without by hearting study. Right? In all simple graph, which is the smallest one? In all simple graph, which is smallest one? Null graph. Forget about what he says. Don't think much about what he says. In terms of edges, I'm talking. Null graph. Which one is the bigger graph? Smallest one is null. Largest one complete. Largest one is complete. Right? Next one. One more thing. In discrete mathematics, which is the scoring topic? In discrete mathematics, which is the scoring topic? Graphs, right? It will give more marks to you, but it doesn't mean that you neglect others. Right? All the topics, see, there is no emotional feeling here. There is no emotions, nothing. This topic I like, that topic I don't like. It is not like that. Everything you have to study once and practice. It doesn't matter what you study when you don't do practice. It doesn't matter what you study, how much you study. It doesn't matter when you don't do practice. So practice is the key. If anyone got nice rank, practice is the key. Practice is the key. So the person who got the first rank this year, the person who got the first rank this year, last year you don't have practice. Last year only syllabus completion itself he completed the time. He don't have enough time, so he got the 500 rank. Last year, this time, right? Last year, right? He completed very late syllabus. Almost like in January, he completed the syllabus. He don't have time, so he got 500 rank. Now this year, he done a lot of practice. He got rank 1. That is the story of this year topper. If you see the Abhinav, right? Before him, Abhinav is the topper. If you see the Abhinav behavior, everything he done in 1 year. Systematically he planned systematically. So approximately September ending he completed syllabus. October, November, December, January, February. Right? Almost like 4 to 5 months he done the practice. So syllabus completion is more important and practice also more important. Both are important. Don't do research in any subject. No emotions, nothing. So I like that, I like this. Who cares whether you like or not? Who cares whether you like or not? In the syllabus, it is there complete. Sir, I don't like that subject, sir. It's okay, but it is a part of the syllabus. Please complete it. Okay, because of you are okay, let's see the next story. Right? Let's see the next story. Everyone listen. Everyone can listen this. Everyone can listen this. So if you want, I will give you the date also. What is the date? Today's date? Is it 15? No. Yeah, I think. Yeah, fine. Sorry for inconvenience. Sorry for inconvenience. Yeah, let's start now. Today date is, I think, 15/05/24. Yeah. Now let's see. Let's see this. Everyone observe. Let's see this one. A, B, C, D. A, B, C, D. Yeah. Can you see? Is it simple graph? Remember, we will discuss simple graphs only. We will discuss simple graphs only. Remember this. We will discuss simple graphs only. Right? So it is a one simple graph. Can you help me now? This simple graph contain how many vertices? This simple graph contain how many vertices? 4. Let me write the names also. A, B, C, D. This simple graph contain 4 vertices. Right? Now what I have to do is, this simple graph contain 4 vertices. Then what should I do is, these 4 vertices, V contain 4 vertices. I have to divide V into 2 parts. M and N. Means out of these 4 people, few people will goes to M group. Few people will goes to M group. Few people will goes to N group. We contain 4 people. Out of those 4 people, right? I have to keep few people in the M group, few people in the N group. How I will keep? Let's see one time. Can you help me now? Between A and B. If you want, you can fix anyone, any group. First person, you keep in any group. A, B, C, D. A, B, C, D. Out of those 4 people, you take anyone, keep in any group. Let us assume, out of A, B, C, D, I will take A. Where I will keep the A? So why are you taking A only? Take anyone, no objection. Take anyone, so okay, I will take A. Now, not only taking A, which group you will keep? M group or N group? Any group you keep. Take the first person, anyone, keep in any group. Okay, I am keeping A here. Now observe. I took A, I kept A in the N group, that is fine. Now see the graph. Now see the given graph. Can you see in the given graph, between A and B edge there? See the given graph. In the given graph, between A and B edge there or not there? Right? Remember, between 2 people edge there, definitely one corner is there in the M group, another corner will be there in the N group. Remember. Take any person first. Keep in any group. Now go to edges, right? So I think A to B edge there, this edge. A to B edge there. So this edge, A already there in the N group. So definitely A to B should be there in another group. Now, once again, those people who are having small doubt, can you see once again now? Can you help me now? A having, is there any one more adjacent? A and B are adjacent, so you already done. A and C also adjacent or not? See, A already there in the N group. Remember, if between 2 people edge there, one corner will be there in the N group, another corner should be there in the M group. So A to C. C also came here. This also completed. Remember, like that, you have to cover all edges. You have to cover all edges like that, every edge. Let's go other people. So some people are asking, sir, B to D also edge there. See this one, B to D also edge there. B already in the M group, D should be N group. If 2 people adjacent, they cannot be in the same group. If 2 people adjacent, they cannot be in the same group. Okay, B to D also completed. Next one, C to D also adjacent. C to D, C and D. Can anyone help me now? Am I cover all edges also? All edges done or not? All edges done or not? All edges done. Now, if you observe clearly, at the end of the all edges, if you observe clearly, within the M, no edge, check. Within the N also no edge. Within the M, no edge. Within the M only, A to C, B to C, no edge. Within the N also no edge. Always edge from M to N. Always edge from M to N. And one more thing is, at group M contain, right? Group M contain, right? Pi, you cannot say pi. M should contain at least one word. M cannot be pi. And one more thing, N cannot be pi. I don't keep in the M group, I don't keep in the N group. You have to keep at least one vertex. In the M, at least one vertex required. In the N, at least one vertex required. And one more condition. Listen, one more condition. M intersection N should be pi. Means no common vertex. Sir, can I keep one vertex in both the places? You cannot keep it. These are the rules. M cannot be pi. N cannot be pi, and one more condition, intersection should be pi, means no vertex is common. And one more interesting thing is M union N should be equal to V. One vertex also cannot miss. Every vertex should be covered. Every vertex should be there either in the M or N. Either in the M or N, but one vertex cannot be in both the groups. One group is pi, you cannot say that. Next one edge is left out. No. One edge is left. No, every edge should be covered. One more thing. Edge is right, every edge from. Right? Otherwise, edges are always from M to N or N to M. No edge within M. No edge within M or no edge from M to M. No edge from M to M or N to N. Right, some people are asking, sir, what exactly you done? Remember, if you can divide the given graph, see this one, if you can divide the given graph G in this fashion, right, if you can divide the number of vertices present in the given graph into two parts M and N, always edge from M to N, within the M no edge, within the N no edge, M cannot be pi, N cannot be pi. Intersection should be, right, M intersection N should be pi, M union N should be V. All edges should be covered, whatever is there in the given graph. Every edge should be covered. If you can partition any graph like this, then G is known as bipartite graph. Then G is known as bipartite graph, which is also called bipartition. Bipartite graph. Are you fine? Then G is known as bipartite graph. That's it. If you can divide the given graph into two parts, M and N, in such a way that M cannot be pi, N cannot be pi, M intersection should be pi, M union N should be V, and every edge of the given graph should be covered. Always edges are from M to N or N to M, but no edge from within the M, no edge right within the N. Then you can say that G is a bipartite graph. Someone is saying N is equal to pi, right? So, sorry for this, both are not. Sorry. Are you okay? Someone is saying any possibility of cycle. Forget about all. This is the meaning of bipartite graph. Within the M, no edge. Within the N, no edge. Always edge from M to N. Always edge from M to N. Every edge should be covered. Right? You have to cover every edge of the given graph. No edge from M to M, no edge from N to N. Right? Next one. All edges of G should be covered. Where is Priyoshi? Where is Priyoshi? Priyoshi, where are you? Right, perfect. Now, anyone having any small doubt also, let me know. Very simple here. I have a graph. Listen, I have a graph. If you can divide that graph into two parts by following these rules, then given graph is a bipartite graph. Otherwise, not bipartite. You getting? I have some people are asking, sir, how the questions will be given? See this one. Don't ask me anything, guarantee you will get. Shakir, everything you will get. Just listen, let me complete. Even definition is going on. Definition is going on, you may not get everything clearly, right? Just give few minutes. When I say that everything done, then definitely you can ask me. Again, I'm repeating. See this one. They will give one graph. They will ask you, this graph is a bipartite graph or not? They will give one graph. They will ask, this graph is a bipartite graph or not? Then what the answer? You have to make sure that graph can be redrawn like second graph. Any graph which you can draw like a second graph, then given graph is a bipartite graph. Second graph means, sir, how, sir? If you want, you can check. See, all vertices are there. In the second graph also, all vertices are there. In the second graph also, all edges are there. The only thing what you done is, right, edge going from A to B. A will be one group, B will be another group. Within the M group, no edge there. Within the N group also, no edge there. And one more, one edge also cannot miss. One vertex also cannot miss. And one more, no group will be empty. M group is not empty. At least M contains one person. At least N contains one person. Right? I hope everyone is fine. Are you okay? I hope everyone is fine. Are you okay? Someone is saying M and N must be equal. Where I written? Are Gootle? Where I written? Where I written M and N equal? Am I written at anywhere? M and N equal? Am I written at anywhere? M and N equal? Anywhere am I written? So it may be, may not be. No rule. The only condition is, JR, the only condition is M cannot be pi. M is pi, no. M cannot be pi. M cannot be pi. Thank you so much for asking. Yeah, so no, I am just asking my doubt. Just I am also talking. That is your way of asking. This is my way of saying. But yeah, that is your way of asking cutely. This is my way of saying cutely. We both are cute people. You are cute, I am also cute. Don't worry about I shouted. I am not shouted. That is my way of saying, right? Don't worry that much. Just ignore, right? Just ignore. So that if I shout, you will remember many days. That is the only intention. If I say so nicely, Jaya Bhaiya, right? Right, both should not be equal. If I say like that, you don't remember. If I beat you one time, you will remember. If I beat you one time, you will remember. Right? Almost beating done. Now, because of you are little bit okay, can you see this? One more interesting story. Can you see this? Can you see this? A, B, C, D. Can I help you now? Is it null graph? Is it null graph? Bhaiya, is it null graph? Remember. Listen, remember, it's a null graph. It is a null graph, 4 vertex null graph. This is also bipartite graph. See, M here, N here, A here, A here, B, C, D here. No problem. If any edge there, M to N. If no edge, no problem. This is also bipartite graph. See, every edge I cover. So it is also bipartite. It is a bipartite graph. You only say where I violated the property. It is a bipartite graph. You only say where I violated the property. If at all edge there, M to N, no edge, no problem. If at all exam there, you should pass. No exam, so pass only. Fine. No exam, pass only. Now, some people are asking, what about this, sir? Some people are asking, what about this, sir? Let's check. First, take C. Take any person, any side. First person can be any side. First person, I will take C. Now C to be edge there, so keep here. Next one, next one, next one. A to D edge there. Yes. So all edges are covered, all vertices also covered. It is also bipartite graph. Fine, till now okay. Till now it is okay. Someone is saying Johan said M is equal to pi. Array, Johan. One time if I kick here, my hand will come from body. From body, hand will come this side. One time if I do like this, my hand itself will come this side. Samjha? Array, clearly I written see. M cannot be pi. N cannot be pi. Right? M cannot be pi, N cannot be pi. Fine? Yeah, I think Jaya saying, sir, my doubt. Sir, last example, M is equal to ABC, N is equal to D, then it is not bipartite. Of course, there may be many ways. Am I right or not? There may be a many ways. See, by satisfying condition, you do whatever way you want. Sir, I can write one more way. It's okay to me. Are you able to bipartite or not? Are you able to divide into two parts or not? That is the only criteria. Sir, slow, right? Show last slide once. This is the last slide. So you may be right. See, you can divide given graph into bipartite. There may be so many ways. One way at least can you give. Can you give at least one way? If you can give, that is more than enough, right? Fine. See, you may say that, sir, I will write one more way, right? I don't have any problem. Are you able to do at least one way? Are you able to do at least one way? That is the story here. I done one way, you may, if at all possibility there, you may be do some other way. But possible or not, that matters. At least one way you can divide. By satisfying the rules and regulations, at least one way can you divide. At least one way. Now listen. Now listen. One more interesting answer. Now listen, everyone. Interesting. A, B, C, D. See the answer. See the answer. Everyone listen. Everyone listen. It is M. It is N. Now take any person. I will take A. A adjacent. Listen. A adjacent is B. Okay. A adjacent D also. Okay. A adjacent C also. Okay. Fine. Until now, fine. So see this one. Totally 5 edges are there. 3 edges are completed. 2 more edges are there. 2 more edges are C to D. Listen, C to D. C to D. You are trying to keep the edge from here to here. You are trying to keep the edge from here to here. So remember, because of this person, it is not bipartite. If anyone say, no, sir, I will write some other way. You write whatever way you want. Please check. If you can write without violating rules, see, we are violating the rules, right? Within the group, how can you keep edge? So it is not bipartite. Not bipartite. Not bipartite. If anyone say now say those people who said that, sir, I will write some other way. Now you write. Yeah, those people who are saying that, sir, I have more possibilities. Now give more possibilities. I tried one way, it's not working. Can you try? Now try. Now show your greatness. Now you people show your greatness. Sir, I can write one more way where property is not violated. Now show. Priyoshi, now show. Priyoshi, now show. Sir, I have more possibilities for null graph. Null graph is bacha. Null graph is bacha. Why are you concentrate on null graph? I done one division. You may do some other division. That is okay. That is okay. Right? Now show your greatness. If anyone says, sir, now I can divide, sir. So I can simply say that given graph is not a bipartite graph because some edges are missing. If I want to keep those edges also, I think what the answer? Bipartite graph definition is failed. How can you keep edge within the n? Edge is always from m to n. Sir, whatever I kept, m to n only. Then what about remaining edges? See, few edges you left out. You have to cover every edge, remember. You have to cover every edge. These two people I am not able to keep inside. If I try to keep, within the n edges are coming. Within the n edges are coming. See, B to D also one more edge. See, B to D also one more edge. Within the n edge cannot be there. Within the n edge cannot be there because of this person. Because of this person, it is not bipartite. Someone is saying, Atul saying, sir, what is the logic behind it? If I want to do it using C program, right? Very simple. I think you may get further. First of all, are you getting the definition? This person, I don't know. I don't know whom Atul will marry. I really don't know whom Atul will marry. He is too much. He is a too much person. He is too much, right? As soon as marriage happened, right? Marriage going on. Just marriage going on. In the marriage function only, I think before marriage maybe engagement there, right? In the engagement time only, right? They both are sitting together. He will say, how many kids we have? What they will study? Array, man, first let's complete engagement. How many kids we have? How many boys? How many girls? Array, first complete engagement. Yeah. Don't torture the people like this. Array, definitions are going on. Definitions are going on, yeah. Array, where is that Abhi? That Abhi person where? Where is that Abhi person? Yeah, present. Where is Nish? One person name is Nish. Where is the Nish? In the last year, one student is there, Kush. Last year, one student is there, his name is Kush. Now, one person, Nish. What nonsense it is. I thought my name only worst. My name only worst names. There are so many names are more worst than me. Yeah, can we go next? Arey, Atul, control, man, control. Atul and Johan, please control, yeah. Please don't kill the people. Please don't kill the people, yeah. Engagement going on, let it be. Let it be. Control. Control yourself, yeah. Your name is so good. Thank you. Thank you, Priyashi. Your name is so nice. She kept butter on me. I am also keeping butter on her. So that, right, both will be cancelled. Yeah. She kept butter on me. I also kept. What is the problem? She kept butter. I also kept butter. So what is the problem? So I think one person saying, I think, yeah, Sayan is saying butter. Why don't you do your business? Arey, Sayan, why don't you do your business? We are keeping butter or ghee. What is your problem? People came. I am not able to join the class. Let's start. Okay. All India problems with you only. All India problems you only have. I think it looks like Vipul is working in the EPT as a tester. In my opinion, Vipul is working in the EPT as a tester. He's working like that. I think so. Every problem you only will get. Sir, why also me? Sir, why always me? I don't know. That's what I'm saying. You are working. I think, I don't know. EPT software like you. It like you. Chalo, can we move further? Can we move further? Can we move further? Can we move further? Yeah. So I think you got the bipartite. Now listen. Now listen, everyone. Now listen, everyone. Now listen, everyone. In the given graph, odd length cycle is there. In the given graph, odd length cycle is there. In the given graph, odd length cycle is there. Yes or no? In the given graph, sir, please upload yesterday's class. Okay. Okay. Yeah. Okay. Okay. Lastly, we will talk. Let's concentrate here. In the given graph, is there any odd length cycle? Cycle there, okay, but odd length cycle there. Remember everyone. Listen, odd length cycle means almost like this. See this one. Odd length cycle means almost like this. Can you see this one? Odd length cycle. Can you see this one? One. Listen, odd length cycle. See the odd length cycle. One. Everyone listen. 1, 2, 3. Within the M edge possible. When you say in the given graph odd length cycle is there, M to N, N to M, M to M cycle there. Odd length. Another way. See the another way. M to N, right? Next one. M to N, odd length. So what I mean to say is, right, in the given graph, everyone listen, in the given graph, every cycle is even length cycle. In the given graph, every cycle is even length. What is the meaning of even length? Even length means I will come and I will go also. Let's see this one. Even length cycle. Can you see the even length cycle? I will go, I will come, until now no cycle. I will go, I will come, again I will go, again I will come. So within the M, no need. Within the N, no need. Right? In the given graph, every cycle is of even length. Then it is a bipartite graph. In the given graph, if you find out odd length cycle, it is not bipartite. Because whenever it is an odd length cycle, right, you can some point of time, you can go only, you cannot come. See this one. You will go, you will come. See, here you are dancing. For this one, only within this you have to do. Right? Both the things if you allow, going also, coming also, every time. Every time 2 if you give, means every time is even length cycle. Then it is a bipartite graph. Right? So in the given graph, every cycle is, in the given graph, let me write the note. Note. In the given graph, in the given graph, no cycle of odd length. In the given graph G, no cycle of odd length. Then G is bipartite graph. In the given graph G, no cycle of odd length. Then G is bipartite graph. Fine? Are you okay? Check one time if anyone having doubt. In the given graph, every cycle, right? In the given graph, no cycle of odd length. No cycle of odd length. If you want, if anyone having doubt, can you go over diagram? See this one? Is there any odd length cycle? See the graph, given graph you see. Odd length cycle, no. Then bipartite graph. See this one, odd length cycle, no. Bipartite graph. Odd length cycle. Where is our one more problem? I think first problem. Odd length cycle, no. Bipartite graph. If odd length is there, you stuck within the group. You stuck within the group. Odd length is there. You stuck within the group. Explain one more time odd length. So what I mean to say is, in the given graph, odd length cycle there or not there. Then what are you doing when it is going on? When it is going on, you are typing. When it is going on, you are typing. Can you listen once again? Can you listen once again? In the given graph, odd length. See everyone? Odd length cycle. 1, 2, 3. Cycle means what? Closed one. Cycle means closed one. It is odd length. 1, 2, 3. 3 length cycle. The problem with the 3 length cycle is, see, 3 length cycle. 3 length is odd length. 3 length cycle. See, 1, 2, 2 edges are over. So 1 more, 3. So within the M there is edge. Within the M there is edge. That is the meaning of this. Or one more possibility, like this. Odd length cycle, this is the problem. Within the M there may be edge, or within the N there may be edge. So any graph which don't have odd length cycle, it is a bipartite graph. Any right? I'm repeating once again. Any graph which don't have odd length cycle, it is a bipartite graph. You got? In the given graph, odd length cycle not there. It is a bipartite graph. In the given graph, odd length cycle not there. It's a bipartite graph. If you want, right? Someone is saying, if even length cycle, we can say bipartite. Yeah, odd length not there. Odd length not there means what is the meaning? Even length maybe, may not. If you see this one, why you talk about even length? Come here. See this one. No cycle. Odd length not there. Simply see odd length not there. It is a bipartite graph. See, odd length cycle not there. Bipartite graph. Why you unnecessarily bring it? Because sometimes no cycle at all. Next one, see, odd length cycle not there. So it is a bipartite graph. Fine. Simple. See the graph. See the graph. Nowhere odd length cycle. It is a bipartite graph. Nowhere odd length cycle. It is a bipartite graph. Even length there or not there. No cycle there. We don't care. Simply odd length is there or not there. That is called bipartite graph. I hope you got it. I hope everyone got it. Anyone having doubt, let me know. See, I may shout. You no need to bother at all. Just see, just my shouting. Listen from this side. Leave from this side. But my shouting reason also there. If I don't shout, you don't listen properly next time. Every time you say repeat. Every time you say repeat. So I have to take care about other people also. I may shout. If you ask me to repeat, right? I don't repeat by smiling. I will shout and I will repeat. So that next time you will be careful. Anyone, any doubt? Check, check. Anyone having any doubt? So can we simply say, if no cycle, then it is also bipartite? Of course. See, no cycle means simply odd length cycle not there. So instead of saying these many sentences, Johan, instead of saying these many sentences, very simple line. What is that? Odd length cycle not there. It is a bipartite graph. Instead of saying these many sentences, one single line. Odd length cycle not there. It is a bipartite. Right? That is more than enough. Fine. You are okay. Let's move to next one. Can we move? Can we move to next? Yeah, if everyone say yes, I can move. I can move to the next one. Can I move? Yeah, fine, perfect. Now see this. Everyone observe. See this also. 4 and 5. Can you see? Is it bipartite? Assume that it is a given graph. Assume it is a given graph. Is it bipartite? Assume that it is a given graph. Is it bipartite? Okay, it is a bipartite. Everyone knows this. It is a bipartite. Now observe. Everyone. Everyone observe. It is a bipartite. Now can you help me now? It is a bipartite, okay. It is also bipartite. Previously bipartite, now also bipartite. Hidden saying that, no, we cannot say. Hidden. One kick if I give, here, total mouth will goes to here. One kick here, one time like this, mouth will goes to here. Is it bipartite or not? Null graph is a bipartite or not? No, null graph is a bipartite graph. See, very simple. See this one. Within the M, no edge. Within the M, no edge. Within the M, no edge. If you can find out at anywhere within the M edge there, then it is not a bipartite. So be careful. So it is a bipartite. It is a bipartite. See this one. If this edge is not there, then also bipartite because nowhere fail. See, M is not pi. Okay. N is not pi. It's okay. Next one. Within the M, no edge there. It's fine. Within the M, no edge there. That is also fine. If at all edge there, M to N. If no edge, no problem. So it is a bipartite. Everyone know this. Unknowingly, Hayden said something wrong. I scolded. Fine. That's okay. Now see the next one. This is also bipartite. This is also bipartite. Now listen. Now listen. Now listen, everyone. This is also bipartite. Listen everyone. In the M, 1 to everywhere to N edge there. In the M, N 2 to everywhere edge there. In the M, 3 to everywhere edge there. Remember, this is also bipartite, but every possibility covered. This is called complete bipartite graph. Completely full. Complete bipartite graph because nowhere gap. If you want, you can check where is the gap. Complete bipartite graph. This graph is called complete bipartite graph because no gap. Some people are asking, how can you say no gap, sir? Can I add one more edge? Sir, I also thought if edge between 1 and 2, so not bipartite. Edge between 1 and 2, no edge, na? Anyhow, can you see this one? Can anyone help me now? Can I add one more edge in this group so that it will become a bipartite? Can I add one more edge in this graph so that it will become a bipartite? Can I add one more edge in this graph so that it will become a bipartite? No, that is the reason it is a complete bipartite. If you add one more, I think definitely bipartite graph definition is gone. This is called complete bipartite graph. Some people are asking, sir, complete bipartite graph, one part contain 3 people, another part contain 2 people. Sir, how to represent? This is the way. Complete means K, right? First part contain 3, second part contain 2. K 3 2. Complete means K. Complete means K. First part contain 3 people, second part contain 2 people. Complete bipartite graph. Why? Right? Because of the bipartite, there are 2 parts. Left part contain 3 people, right part contain 2 people. Complete. So okay. Bipartite. So 3, 2. First one contain 3, second one contain 2. This is called complete bipartite graph. Now some people are asking, sir, then a complete bipartite graph, K 3, 2. How many edges are? See this one? Number of edges in K. Number of edges in K 3 2 is equal to. What is the answer? Every person having 2 edges, like that 3 times. 3 into 2, 6 people. 6 edges check. In the similar way, complete bipartite graph, K, M, N. M people left side, N people right side. Total number of edges are Mn. Remember this formula for not bipartite graph, complete bipartite graph. Complete bipartite graph. This formula only for a complete bipartite graph. Can anyone help you now? I want answer from you. Can you help you now? Not complete bipartite graph, simply bipartite graph. See this one? Bipartite graph. Everyone listen. Bipartite graph where one group contain M people, another group contain N people. Can you help you now? Total how many edges are there? Number of edges how many? Minimum edges how many? Minimum edges how many? Bipartite, it's a bipartite graph, remember. Bipartite graph where left contain M people, right contain N people. Minimum edges how many? I think M to N, no edge there, 0. Maximum edges how many there? maximum edges how many there? Because of the bipartite, maximum is complete. So MN. This is the story for bipartite. This is the story for complete bipartite. In the complete, listen, in the complete, no maximum, no minimum. In the complete, every case this one. Maximum also this only, minimum also this one. Because it is already complete. Already complete. What is minimum? What is maximum? Yeah. It is already complete. What is maximum? What is minimum? Are you okay? Bhaiya, are you okay? Almost everyone got. Everyone got. Everyone got. Almost everyone got. Almost everyone got. Yeah, fine. Now, let me ask you one small line. Let me ask you one small line. Everyone, who will get the rank? The people who prepared first 1 month, first 2 months, or first 3 months. Who will get the rank? Who will get the rank? The people who prepared first month, second month, or third month. Who will get the rank? Right? Until exam over. Until exam over. Until exam over. You have to keep on work. So you only say, I am not going to be a good teacher. I am not going to be a good teacher if I teach only 1 month. If I teach only 1 month, you don't give the good rating to me. Right? So second month also I taught. Okay, fine. Third month also fine. Entire year if I do, entire year. Exam is, let us assume that exam is in Feb. I stopped services, right? From the January itself I stopped. Still you will give 0. I given the training to you until January. January ending, I will stop because exam is there in the February 10th. Those 10 days, I didn't done any service. Even though I done from there to there, right? Exceedingly so well I done. But last 10 days, I am not done. You will give the negative feedback to me. This person don't support us. This person is money-minded. This person will take money, you don't give service. By a same thing to you also. Not only to me, same thing to you. Everyone, same rule. Every day I should work. Then only I will get the nice name. Every day you should work. Then only you will get the nice name. To me, one rule. To you, one rule. No. Rule is for everyone. So if I don't work 1 week, guarantee you will say, Arey, Reddy sir is not good. Not good person. Same thing, same. Same thing. GATE also thinking same. Oh, right? Johan is not good. Last 1 week is not studying. GATE also thinking same. Oh, Johan is not good. Jaya is not good. Ashwini is not good. Next one, Vipul is not good. Same thing, Bhaiya. Everyone same. That is the reason. God is there. God is there. He is watching from top. Please be responsible. Suddenly, see, if you want to can verify. If you want to can verify, last 5 months, lot of dust will come. Lot of dust. You don't know how many people will be there inside this platform. You can't imagine. You can't imagine how many people will be there inside this platform. Lot of dust will come. See, many people on this earth, many people who don't have any planning. All dust will come. All dust will come. How to crack GATE exam? In 3 months only. 3 months, right? 90 days, AIR below 90. I will make one YouTube video also. How to get the AIR 100 in 100 days. How to get AIR 100 in 100 days. All dogs will come. All dogs will come. How to get one more person I seen. Right? So many dogs I seen in the last month. How to get AIR 1 in 30 days. How to get AIR 1 in 30 days. How it will work, I don't know, yeah. How people are getting hot to keep that video also. But still I will keep. I don't get hard to keep that particular video, but what can I do? Because of business, I will also keep. How to get AIR1 in just 30 days. In just 30 days. You know those people who will come to see that video. If I have gun, I want to fire them. How to get AIR1 within 1 month. Whoever will open that video to watch it, I want to take one gun, right? Online gun. I want to shoot him. I want to shoot him. So what I mean to say, everyone, is please do from now onwards. Life becomes so easy. You are going to get a very nice rank, at least from now onwards, if you are consistent. Don't neglect one day also. Don't neglect one day also. I can also neglect. See, Saturday, Sunday, I give a holiday. Because you also need rest, you also to revise the notes. But right, if I do like this, syllabus will not go over. So that is the reason multiple subjects. If I go only one subject, right, then I have to take Saturday, Sunday also. If I go multiple subjects, right, Saturday, Sunday, I can give leave and you can revise the notes and you can prepare for a test also, right? Come to the next. Everything is ready, come to the next. I think bipartite graph, complete bipartite graph. Is everything okay? First of all, complete bipartite graph is a bipartite graph or not? First of all, complete bipartite graph is a bipartite graph or not? Remember, same condition will hold good, right? For complete binary tree, complete bipartite graph also. What is the rule? In the given graph, there is no odd length cycle. In the given graph, there is no odd length cycle. It is a bipartite graph. It is a bipartite graph. Please be careful. In the given graph, there is no odd length cycle. It is a bipartite graph. Is it complete or not? You can verify this. Is it complete or not? So see this one. Every m to every n, there should be edge. If one edge also missing, it is not complete bipartite. It is simply bipartite. Every edge from m to every edge of n should be there. Every vertex of m to every vertex of n edge should be there in the given bipartite graph. Then it is called complete bipartite graph. The number of edges are, this is the formula. Right? If at all simply bipartite, there is no formula. Minimum is 0, maximum is mn. Minimum 0, maximum mn. In between, anything can happen. In between, anything can happen. I hope everyone got it. Can I move to next? Can I move to next? We done really nice work. So remember, complete bipartite graph is really useful. I explained so nicely. I started from here, bipartite graph. Today's class started from here. Definitions I started. Right? So yeah, perfect. Now come to next one. Everyone listen. Come to next one. A, B, C, D, E. Can you help me now? This graph contain how many vertices? This graph contain how many vertices? How many? This graph contain how many vertices? 5 vertices? 5 vertices. I think one person you kept in the middle. Out of 5 people, one person you kept in the middle. So if you see outside, 4 people are there. For every person, one edge there. Can you help me now? This graph which contain 5 vertices, how many edges are there? This graph which contain 5 vertices, how many edges are there? Only 4 or not? Remember, this is called, everyone listen. This is called 5 vertex star graph. 5 vertex star graph. See, in the form of star it is there. 5 vertex star graph. Remember, 5 vertex star graph contain 4 edges. Because one person is in the middle. 5 vertex star graph contain 4 edges. And one more beauty. Listen, one more beauty. Listen, 5 vertex star graph contain 4 edges. That is okay. One more beauty. Can you see this one? One more beauty. Every star graph can be written as a bipartite graph. How? This A will be at first place, right? B, C, D, E in the second place. Edge from here to here. Am I right? Every star graph will be written as bipartite graph. So that bipartite is going to be complete bipartite. See this one. Star graph with 5 vertices can be written like this, which is also called as complete bipartite graph with vertex partition 1, 4. Left side 1 person, right side 4 people. So the number of edges are 1 into 4. 4 edges are there. So remember, 5 vertex star graph is nothing but complete graph with the vertex partition, complete bipartite graph with vertex partition 1, 4. Only 4 edges are there. Anyone having any doubt, let me know. This is called star graph. Very simple. Someone is saying no audio. Someone is saying no audio. Is it so? Yeah, maybe some network issue. Maybe some network issue. Yeah, are you okay with the star graph? Are you okay with the star graph? Yeah. So if you okay with this, can you see? Can you see this line? Can you see this line? Everyone listen. Everyone listen. 100 vertex. 100 vertex star graph. 100 vertex star graph, which is nothing but, listen, 100 vertex star graph, which is nothing but K 1, 99, which is also called as 1 into 99 edges. So 99 edges. Check properly. Everything okay. One time listen here. As much knowledge as possible. Gain as much knowledge as possible. Don't worry about rank. Please do everyday good work. See, some people don't do necessary work. Every day they will think about rank only. Then you don't get rank, you don't get knowledge also. But some people, they never bother about rank. They will always bother about knowledge. They will always bother about how to complete syllabus. They will always bother about how to practice. If you do necessary thing, everything will come. Do necessary thing. Result is the byproduct of the small thing what you do every day. Not what you do extraordinary thing one day. Not what you do extraordinary thing 1 week. The small thing what you are doing from first day to last day, right? Result will come byproduct of all these things. Just concentrate knowledge. Just concentrate completing syllabus. Just concentrate practicing. Automatically everything will follow you. I've seen many people. See, there is a one person last year. His name is Ratul. There is one person, his name is Ratul. Right? Last year he done nice work. Listen, he done nice work. Very good work he done. I thought he will be there top 100. I thought he will be there in top 100. Because of whatever it may be the reason, he got 700 rank. He got 700 rank. But he have knowledge. You know what happened? Right? Yeah, I will check once. See this one. So last year GATE examination, he written the exam, he got 700. I thought he will get below 100. He got 700. You know what happened? So almost he cried. But one thing he understand. What is that one? He done lot of hard work. So where it will go? So every IIT applied. Every IIT applied, right? There are some seats are there based on the written test and interview. Based on the written test and interview, they will give the seats. Right? He applied for IIT Madras, right? So I think he got selected. He got selected for the written test and interview. Because of he didn't get the nice rank, he didn't get directly, but he applied for the MS program, not MTech, MS. That may be 2.5 years. He applied for MS, right? Written test and interview is there. So he cleared both. He got selected. If you have knowledge, somehow it will come back. Unfortunately, some path is closed. Another path you can go. If you don't have knowledge, right? It will kill you, I am saying. Please gain as much as possible. I think Johan asking in the previous diagram there should be two MN edges. Can you go back and check? How? How? Yeah. Can you check? It is not sum of degrees. It is not sum of degrees. See, 1 into 4. 4 edges are there. Check 1, 2, 3, 4. 4 edges. If I write 2 into, it could have been 8 edges. Count the edges. I am not asking sum of degrees. Yeah, number of edges. Sum of degrees are double, but number of edges are 4 only. Is it okay? You are misleading, right? You are misleading. That is the sum of degrees. It is a number of edges. Careful. Okay, I think star graph also everyone is comfortable. Star graph also everyone is comfortable. Now let's see one more graph. Let's see one more graph. Star graph is over. Let's see one more graph. One more small graph is there. I will do that also. One more small graph is there. I will do that graph also. Right? I will do that graph also. Make sure everyone listen. Make sure everyone listen. Madam, cycle graph. These are small things. These are small things. One time if you listen enough. Cycle graph. A, B, C. See this one. Nothing there. Cycle graph means nothing. 3 vertices. There are 3 edges with cycle. This is called C3. Next one. 4 vertices. There are 4 edges with cycle. This is called C4. Cycle graph with 4 vertices. Next one. There are 5 vertices. There are 5 vertices with 5 edges with cycle. This is called C5. Right? Until now, everyone fine. This is called cycle graph. Now try to understand. Can anyone help you now? Complete graph. What is the starting letter? Complete graph. What is the starting letter? I want answer from you. Complete graph. What is the starting letter? C or not? Complete starting letter is C. Sir, complete graph is starting letter is C. Why are you using K, sir? Complete means C, na? Then why you written K, sir? Remember. C already given to cycle graph. That is the reason. Because of C already given, let's give some other name for the complete graph. They kept K. That is the reason. Some people may be thinking that actually complete graph 1, 5. Right? I written K 1, 5. Some people are thinking it is a C 1, 5. No, bhaiya. C given already for cycle graph. C already given for cycle graph. Please try to understand. Now it's the correct time to ask you. Listen, it is the correct time to ask you. Cycle graph, everyone listen. Cycle graph with 25 vertices. How many edges? Cycle graph with 25 vertices. It is represented C25 contain 25 edges. Next one, cycle graph with n vertices, right? So contain n edges. Simple cycle. It's a very simple one. And one more. It's an odd length cycle. It is an even length. Cycle graph of even length. It's an odd length. Cycle graph of odd length. Fine. Bhaiya, fine. Now, can I say like this? Every cycle graph of even length is a bipartite. Every cycle graph of even length is bipartite. Every cycle graph of even length. Can I say bipartite? Of course. See, I cannot say every cycle graph is bipartite. I cannot say every cycle graph of even length is a bipartite. Every cycle graph of even length. I cannot say every cycle graph is a bipartite. Every cycle graph of even length is a bipartite, right? Because of meaning is same. Odd degree, right? Listen, odd length cycle not there. It is a bipartite. Indirect, directly same meaning. Odd length cycle is not there. It is a bipartite. Indirectly, directly same meaning. But here see, odd length cycle. It is not a bipartite. It is an odd length cycle. It is not a bipartite. If you want, you can check. If you want, you can check. Within the M there is edge, or within the N there is edge. Some problem will come. Okay, fine. That is because of everyone is comfortable. Listen, I am writing. Can you see this one? Cn, where n is even. Cn, cycle graph with n vertices where n is even. It's bipartite graph. Cn where n is even, so it's a bipartite graph. Okay, perfect. Everyone is comfortable. Can you listen one more small keyword? One more small keyword there. Listen carefully. One more small keyword. A, B, C. See the interesting answer. A, B, C, D. Is it cycle graph? Bhaiya, is it cycle graph? Is it cycle graph? Can I say C4? Is it C4? Yeah. It is a cycle graph with 4 vertices. It is a C4. Now see what I am doing. Cycle graph with 4 vertices, right? C4. That's okay. What I will do is, listen, I will take the same diagram as it is. Same C4 I will take as it is. Okay, take as it is. Fine. After taking all the people as it is, one more vertex E you write inside. Keep this person to every other person edge. This is called wheel graph. This is called wheel graph. This is called wheel graph with 5 vertices. Wheel graph with 5 vertices, which is called W5. But remember, wheel graph with 5 vertices, W5, is derived from cycle graph with 4 vertices. Take the same C4, right? You want W5, take C4, inside add 1 vertex. And for every person, edge you write. Then it is called a wheel graph with 5 vertices. Remember, wheel graph 5 vertices is derived from cycle graph with 4 vertices. W5 derived from C4. The only thing is one more new vertex take. From that vertex to all other people keep edge. This is called wheel graph of 5 vertices, which is derived from cycle graph of 4 vertices. If anyone is not getting it, I will give one more example. Can you see this? Can everyone listen? A, B, C, D, E, and F. How many vertices this? Can you check how many vertices here? Here, how many vertices? A, B, C, D, E, F. How many? I think 6 people. It is a C6. It is a C6. Add one more. F is this. It is a G. This person to every person, right? This is called, total diagram is called W7. Without inside person, it is a C6. With the inside person, it became W7. Only outside is C6. Right? Inside, right? Outside is outside, sorry. Only these parts. These people are C6. But if you take the total, W7. Now listen. Very interesting answer. Can you help me now? W7 is derived from C6. C6 contain how many edges? Number of edges in W7. is equal to, can you see this one? Number of edges in W7 is equal to. Can you see it is derived from C6. C6 contain how many? 6 edges. C6 contains 6 edges. And one more. Inside person, new person. New person is adjacent to all other people. One more 7 minus 1. One more 6. W7 contain, first of all, 6 edges because outside people check. So these are these people. If anyone is not getting, can you see this one? W7 contain how many edges? First of all, it is a C6. So C6 contains 6 people. Outside people are 6 people. Outside people are 6 people. Okay, this is for outside. But inside you added, so 6 more. Inside you added 6 more. Total, if you see the total, how many edges? 2 into 7 minus 1. So 2 into 6, totally 12 edges. Count if you want. Which can also be written another way. Can you see this one? Number of edges in Wn. Remember, Wn is derived from Cn minus 1. Cn minus 1 contain n minus 1 edges. Next one, inside person having n minus 1 edges again. Total 2 into n minus 1. Is it okay? Check, anyone having doubt? This is called wheel graph with 7 vertices, which is derived from cycle graph with 6 vertices. Bhaiya, fine, is it okay? They are very, very small thing. One time listening, meaningfully study one time. 2 or 3 times you revise, make one short notes. Total graph theory, you have to make 5-page notes. Total mathematical logic, you have to make 5-page notes. Total discrete mathematics, you have to make 20-page notes. That then only you are doing the good work. Who will study every time, starting to ending, 300-page notes? How can you read? Whenever you say discrete mathematics, mathematical logic completed. Do 2 or 3 rounds. Everything is okay. Now write down important points in 5 pages. Next one, graph theory. Total graph theory is over. Right? See, what is the important one? 1 or 2 revisions do. Yeah, whenever you got to know everything, fine. Make 5-page notes. Write 50 pages in 5 pages. Mathematical logic contain 50 pages is in 50 by 10, 5 pages. Graph theory, 50 pages, 50 by 10, 5 pages. So total discrete mathematics, 300 pages by 10, 30 pages. Maybe 25 pages, something like that. Same thing with the algorithm also. You should have one long notes, you should have one short notes. Sir, if I keep on making the notes, time will be over, but you are gaining knowledge also, you are not making blindly. Right? So one time writing a notes is nothing but, right? You will remember many days. One time writing is nothing but 10 times reading. You will remember many days. One time, that is the reason when I'm a kid, when I'm a student like you, my teacher used to give some homework, right? Just copying only. Can you copy this? Right? If you write the same sentence 100 times, you never forget it. That is the reason you didn't forget it. The A, B, C, D, E, F. You didn't forget it because many times you write down. If you write the notes one time meaningfully, which is equal to 10 times study. Yeah, perfect. Yeah. So is it okay? Till now, okay. Check. We done very, very important things, right? From now onwards, one more small thing there. With that, right? We done the decent work. Today we done decent work. If you are comfortable, tomorrow we will do some problems on graph theory. Tomorrow we will do some problems on graph theory. Until now we are not done any problem. Check, are you comfortable till now? One small story pending. I will do that also. Let's write the next one. Let's write the next one. Planar graph. Next one is planar graph. What it means, I will see now. Listen this also. This will come many times. In the total graph theory, I don't know how many times it came. Next year also you can expect one question from here. Next year also you can expect one question from here. Right? This right name is called planar graph. Name is known as planar graph. Right? Let's see. See everyone concentrate. Everyone concentrate. See this. A, B, C, D. A, B, C. Can you help enough? Is it K4? Please concentrate this also. Concentrate this also. You done decent work till now. Till now you done the very good work. Till now you done the very good work. Can you concentrate this also? This is the highlight of today's class. Today's class, this is the highlight. Highlight of the today's class is this only. Right? So, right, topic is planar graph, but I written K4. Topic is planar graph, but I written K4. Now see the answer. Now see the answer. Everyone observe. Take the all vertices as it is. Topic name is planar graph. I took K4. See what is happening. Take all vertices as it is. In the given graph, whatever vertices are there, take as it is. Okay. Now you have to shift all the edges which are there in the left graph to right graph. Let me shift. First edge I am shifting. Okay. Right, next one. Second edge I am shifting. Okay. Third edge also I am shifting. Fine. Fourth edge also I am shifting. That is also okay. Until now, do you have any problem? I took one graph, K4. In that graph, how many vertices are there? I written all the vertices as it is. Now, in the left graph, whatever edges are there, I am shifting one by one. Can you say until now, how many edges I shifted? Until now, how many edges I shifted? 4. How many edges left out? Totally, I think 6 edges. 4 I already shifted. I think 2 more edges are there. Those also I want to shift. Listen, those also I want to shift. So I'm shifting. Can you see this? I'm shifting. Everyone observe. I'm shifting. So B to C edge there. I shifted that also. Now can you help me? How many edges left out? How many edges left out? One more edge left out. Now observe everyone. Everyone observe. Until now, no problem. Now problem will come. Now problem will come. Can you see? Now problem will come. So every edge I shifted. Now one more edge is there, A to D. Can you see this one? A to D. If I write the A to D like this, if I do the A to D like this, is there an edge crossing? Is there any edge crossing? If I want to write A to D, is there any edge crossing or not? Remember, if you can draw the same graph as it is without edge crossing, then it is called planar graph. If you can draw the same graph without edge crossing, then it is called planar graph. Now let me try without edge crossing, means without touching another edge. Without touching another edge, I have to write it. See how I am writing, very interesting. See this one, how I am writing. So you have to draw that edge also without edge crossing. I think I can go like this. Am I right? Can I go from outside? If I come inside, edge crossing going on. If I come inside, edge crossing going on. If I go outside, edge crossing not there. So you are able to draw same graph without edge crossing. Then the given graph is a planar graph. Because of this reason, it is a planar graph. Because of this reason, it is a planar graph. Can you draw the same graph? Can you draw the same graph without edge crossing? Then it is planar graph. That's it. If anyone say from today onwards, I have a graph, I want to say that graph is a planar graph. How can you prove it? Very simple. Draw the same graph without edge crossing. If you see any edge crossing in the given graph, can I draw it without crossing? Can I draw it without crossing? Some people are asking, sir, what is the meaning of crossing? Some people are saying, what is the meaning of crossing? Can't it be crossing? It is a crossing. Can't it be crossing? Are you getting? So this is also crossing. At anywhere, if you find out that kind of behavior, that is not a planar graph. That is not a planar graph. Right? Please careful. Now, because of your little okay, now I want answer from you. Everyone try. Everyone try. Is K3 is planar? Is K3 is planar graph? If you see the K3, is it direct planar or not? See, edge crossing not there. Edge crossing not there. Where is the edge crossing? Nowhere edge crossing. Yes. Fine. Nowhere edge crossing. Yeah, someone is saying, right? Someone is saying some other number. We will see now. We will see now. Listen, K4 I tried. It is a planar. K3 is a planar. Yes, that is also. Now listen, observe properly. So I think if you want, you can verify. K2, there is no meaning of K2. K2 also planar. These are small things. K1 means only one vertex. That is also planar. So this is the K2. Two nodes. That's it. K2. This is the K1. So this is also planar. This is also planar. Remember, K1 planar, K2 planar, K3 planar, K4 planar. Now, can you check yourself? Until which point it is a planar? Let's check. K5. What about K5? K5 is planar. Let's see. Someone is saying K5 is non-planar. Let's check one time. Don't say blindly. Try for this. K5 is planar or not? Verify. First to draw K5. First to draw K5. First draw K5. What some people are, how K5 look like? 5 vertices. B, C, D. So K5, you know how many edges are there in the K5? In the K5, how many edges are there? 5 vertices, every vertex degree 4. This is the sum of degrees by 2. So I think the 20 by 2, 10 edges. Total 10 edges, it is a K5. So you have to draw 10 edges without any crossing. Without any crossing, you have to write 10 edges. I think it's a very challenging task. So I'm starting. See, I'm starting. So inside people, 5 people. 5 people inside. Total 10. 5 people are outside. Is it okay? Total 10 people. 5 people are outside. Any crossing till now? Total 10 edges. Outside 5 people. So until 5 people, there is no problem. Now be careful. Be careful inside. Be careful inside. Here also no problem. Here also no problem. Yeah, but unfortunately, so D2C, if I want to write D2C, if I want to write D2C, if I go inside problem coming, from outside I will write. It's okay till now? Total, listen everyone now, total 10 edges. Outside 5 people are already done. Inside I kept already 2 people. 5 plus 2, 7. From outside I written one more one. Total 8 over. How many edges left out? Bhaiya, how many edges left out? 2 more. 2 more. From where to where? 2 more. From where to where, Bhaiya? 2 more edges are left out. I can understand. From where to where? A to D. A to E also. See the answer. A to D. Okay. Can you see how many edges are left out? How many edges are left out? A to D also over. I think only one person left out. A to E. Arey man, everywhere closed. Can I go upper? Can I go upper? He is saying no. Can I go niche? Can I go inside? He is saying no. Am I right? I think there is no way. Inside also problem is coming. Inside also problem is coming. From outside also problem is coming. So I think one edge left out. One edge left out. You try any manner. So one more edge I am not able to complete. So I will use another color also. I will use another color. So if I want to do this, if I want to go like this, here crossing way. If I want to go like this, here crossing way. So what is the answer? It is a non-planar. It is a non-planar. Remember everyone. Remember everyone. Kn, listen, Kn where n is greater than or equal to 5. 5 or more than 5 is non-planar. Kn where n is 5 or more than 5 is non-planar. 5 itself is non-planar. If you go 6, can you see how many edges? K6 contain how many edges? 6 into 5, 30 by 2, 15 edges. K6 contain 15 edges. 6 into 5, 30 by 2, 15 edges. Covering 15 become very difficult. Many edge crossings may be there. So remember this is the node. Kn where n is greater than or equal to 5 is non-planar. Sir, Reddy sir, you are writing the notes. Box wise you are writing. I will also write. Array copycat. So see, someone is saying you written the boxes. I will also write boxes. You are writing the boxes. I will also write. Everything copy your life. Your life is everything copy. Cyan, can't you write your own notes? Everything you will copy. Can't you write your own notes, yeah? Everything copy. See, I am keeping boxes. You are also keeping boxes. I seen in our group. One person notes. Boxes are there. Whatever way I written the boxes, he is also writing. He is also writing boxes only. I will keep circle. Go to hell. Go to hell also. Go to hell. In my notes, boxes are very less. Okay. Okay. Move next. Priyoshi is saying, stop acting, go to next. Priyoshi indirectly saying, Reddy sir, stop acting. Please stop acting, go to next. Okay. Okay, madam. Okay, madam. Thank God she is not my teacher. Thank God she is not my teacher. She could have beaten me many times. Now, can we move to next? I think planar graph we done. Yeah, one more small thing there. Observe this. One more small thing. Careful. One more small thing there, please check. K 2, 3. Let's see is it planar or not. Let's see is it planar or not. Let's check. Let's check this. K23. K23 is it planar or not? First of all, draw the diagram. 1, 2, 3. 2, 3 means what? Left side 2 people, right side 3 people. So this person to all. Okay. See the answer. This person to all. And one more. Can you see this one? Can you see this one? Like this, and like this. Any problem? 1, 2 everywhere. 2, 2 everywhere. Any problem? 1, 2 everywhere. 2, 2 everywhere. Any problem? No problem. It is a planar. It is a planar. We are already proved also. Yeah. If you okay with this, can you check? Can you check? K23 itself is planar. Can you try this? K25 or 24. Can you try this? Check one time. K24. Yeah. Now see this one. K24. Can you see this one? 1, 2 here. 1, 2 here. 3, 4, 5, and 6. So first person you can do all. See, if you see the second person, second person is I think very easy. See this one, 1, okay. This is 1, okay. Second person, if you observe, this is 1, okay. But remaining all, I think happily you can write like this. Like this happily from outside you can write. It is also planar. It is also planar. If you want, you can verify K25 also. K25 also. If you want, you can check. So this is a planar. And one more. K25 also planar. K210 also planar. K117 also planar. If you want, see, 2 itself working. Left side 2 itself working. Guaranteed it will work. But see the story. See the story. What about K3? Listen everyone now. What about K32? See the answer. K32. 1, 2, 3, 4, and 5. Can you help me now? Can you help me now? K32, K23, both are same. Am I right? Can you help me now? K23, K32, both are same or not? Who bother what is M, what is N here? Who bother what is M, what is N? Two groups you have to divide. Two groups you have to divide. So whatever you done over a diagram, just reverse it. Whatever you done over a diagram, just reverse it out like this. Just reverse it. Now this person will go like this. Remaining all the people, you can move like this. Right? Now see the beauty. It is also planar. Everyone know this because both are same. This is equal to this one. Both are same. Order doesn't matter. Now see the major problem. Now see the major problem. K33. Listen everyone now. K33. To get the problem, minimum these two people are 3. Minimum these two people are 3. Let's check. 1, 2, 3. If you want, you can verify. 1, 2, 3, 4, 5, 6. Check now. This will go all. Okay. This will go all. Okay. Next one. Next one. I think second person also you can manage. You know, like this from outside you can do. Okay. That is also okay. So until now you can manage. Now see the real challenge. 3 will kill the life. See this one. 1 covered. What about 3 to 5? What about 3 to 4? If I go inside, so many edge crossings. If I go outside, see this one. If I go outside, this person also no problem. 3, 5 also no problem. 3, 6 also no problem. But 3, 4 having serious issue. Suppose if you want to go like this, he will cross. Suppose if you want to go like this, he will cross. So because of edge crossing there, so remember everyone, K33 non-planar, right? You see minimum 3 non-planar. And this one 3, 4 guarantee non-planar. Check K, right? So 4, 3 it is also non-planar. So from this conclusion Km comma n such that m comma n is greater than or equal to 3 is non-planar. Please careful. Kn is non-planar. What is the condition? This is the condition. Kn where n is greater than or equal to 5 is non-planar. That is the note. Next one, Km comma n where m comma n is greater than or equal to 3 is non-planar. This is one more note. Careful. This entire story came from here. It is a non-planar. See, hidden is written. See, hidden. All bipartite is planar. Hidden bhaiya, control bhaiya. All bipartite is planar. Now, is it okay now? Is it perfect? Is it perfect? If you want, I can write both the notes once again. Note 1. I am writing the note 1. See this one. I am writing the note 1 once again. Note 1. What is the note 1? Kn where n is greater than or equal to 5 is non-planar. Next one, Km comma n such that m comma n is greater than or equal to 3 is also non-planar. Is also non-planar. So note 2. Bhaiya, sahi hai? Yeah, you can take rest now. So when you want class 8, right, 9 or 9:30. When you want class 9 or 9:30. Decide whenever you want. Anytime ready. Priyosh is saying anytime. It is your wish. Okay, 9:30. Chalo 9:30. Chalo. Gayatri, good night. Priyoshi, good night. Shakir, good night. We'll meet at 9:30. Yeah. Good night everyone. Bye. Are Johan, good night. We will meet he. Who is he? We will meet he. What is that? Oh, smiley. Okay. Okay, fine. Chalo. Chalo then. Chalo, bye. Thank you. Someone is saying, miss you until 9:30. Arey, Shakir. Shakir, why don't you jump from 3rd floor? Blunder. What blunder? Chalo. I don't want to waste my time with the dogs. 10th floor is only, na? Okay, go to 10th floor and die. Go to 10th floor and die then.